Hello there, and welcome to Life Beyond Seen, where curiosity slows its pace, questions soften their edges, and science wanders gently enough that sleep is always welcome to join the conversation. Tonight, we're drifting far from shore, far from schedules, far from anything that expects you to be alert or productive. This is a place for wandering without urgency, for learning without effort, for letting thoughts loosen their grip as the world grows quieter around you. Out there on our planet, beyond coastlines and shipping lanes, beyond flight paths and radio chatter, there is a place that exists more as an idea than a destination, a point defined not by what is there, but by what is not. No cities, no islands, no familiar landmarks, just water, layered and moving, stretching in every direction farther than the eye or the imagination feels comfortable travelling. This place has a name that sounds almost friendly, almost casual, yet it marks the most remote location on Earth's surface. It is known as Point Nemo, and calling it mysterious is not an exaggeration or a marketing flourish. It is simply accurate. The ocean covers more than 70% of our planet, yet most of our mental maps stop at beaches, reefs and shipping routes. We think of the sea as something you can point to from land, something you reach and then turn back from. But Point Nemo is not something you arrive at by accident. It is not something you stumble upon while sailing or flying. It exists because humans measured absence. It exists because someone asked a quiet mathematical question. Where is the place on Earth that is farthest from any land at all? There is something gently unsettling about that idea. Not dangerous, not dramatic, just deeply indifferent. A place so far removed from human presence that even the usual markers of distance stop feeling useful. Kilometres and miles become abstract when there's nothing to count them against. No lights on the horizon, no radio stations fading in and out, no birds signalling proximity to land. Just water, sky, and time moving forward at their own unbothered pace. Before we drift any farther, let me pause for a moment and ask you something simple. Where are you listening from right now? Maybe you're in a familiar room, surrounded by quiet objects you know well. Maybe you're travelling, tucked into a temporary space that still feels a little strange. And what time is it there for you? Early evening when the world is winding down, or deep night when thoughts tend to roam more freely. It's interesting, isn't it, that while we're talking about the most distant point on Earth, we're all anchored very firmly to our own small, immediate corners of it. If you find this kind of slow exploration calming, or if it gives your mind something gentle to rest on, you're always welcome to like the video or subscribe. It helps this quiet corner reach others who might need a pause like this one. Nothing urgent, nothing loud. Just a small nudge in the background while we continue. Now, imagine looking down at the Earth from very far away. Not the dramatic cinematic view with glowing cities and crisp coastlines, but a more honest one. A globe wrapped in swirling clouds, vast blue surfaces broken only occasionally by thin threads of land. From that distance, the ocean looks continuous, almost uniform. But hidden within that blue is an address with no neighbours, a set of coordinates that represents maximum isolation on the surface of our planet. Point Nemo sits in the South Pacific Ocean, surrounded by thousands of kilometres of open water in every direction. Its nearest bits of land are not continents or bustling islands, but tiny uninhabited specks. Ducie Island to the north, Motu Nui, a rocky islet near Easter Island to the northeast, Maher Island off the coast of Antarctica to the south, each of them so far away that even listing their names feels like a formality rather than a reassurance. What makes this place different from other remote parts of the ocean is not depth alone or storminess or cold. It is geometry, pure, quiet geometry. If you were somehow floating at the surface there, the closest humans to you would likely not be on Earth at all. They would be orbiting above you, aboard the International Space Station, passing overhead every 90 minutes or so. For brief moments, the nearest people would be separated from you not by water, but by vacuum. That fact tends to linger in the mind once you hear it. It reframes remoteness into something almost cosmic. Most places on Earth, no matter how wild, still belong clearly to the planet. Point Nemo feels like a seam, a place where Earth thins out socially, culturally and psychologically, even though it remains physically solid and very much alive. The water there is not empty, despite how often we use that word. It moves in layers, carrying nutrients, heat and microscopic life. Currents slide past one another without regard for borders or names. The surface may appear calm or restless depending on the day, but beneath it, processes unfold that have been happening for millions of years. Slow circulation patterns connect this lonely spot to the rest of the world ocean, even if no ship passes through for months or years at a time. And ships really don't pass through. Commercial routes avoid it because there is no reason to be there. No ports, no shortcuts, no fuel savings. Fishing fleets tend to work closer to continental shelves where life is denser and easier to harvest. Research vessels sometimes cross nearby, but even they rarely stop precisely at that point. There is nothing to anchor to, nothing to study that cannot be studied more conveniently elsewhere. Which raises a curious question. If there is nothing useful there, nothing profitable, nothing scenic in the conventional sense, why does Point Nemo capture the imagination at all? Part of the answer lies in how humans relate to extremes. We mark the highest mountain, the deepest trench, the hottest desert, not because these places are comfortable or practical, but because they define the edges of our experience. They tell us where the familiar ends. Point Nemo does that not by towering above us or plunging below, but by stepping away entirely. It is the farthest you can be from land while still standing on the surface of the Earth. There's also something quietly modern about how it was discovered. No ancient sailors told stories about it. No myths warned of monsters there. It did not enter human awareness through exploration or survival, but through calculation. In the 1990s, with satellite data and improved mapping of coastlines, scientists could finally determine with precision where the ocean's point of maximum inaccessibility lay. The result was not a revelation of something new in the physical world, but a realization about how that world is arranged. That distinction matters. Point Nemo did not suddenly become lonely when we named it. It had always been that way. We simply noticed. Noticing changes how we think about a place. Once something has a name, it becomes harder to ignore. It starts to attract stories, interpretations, and questions. People begin to wonder what it would feel like to be there, what the sky looks like at night, whether the ocean sounds different when there are no ships, no distant engines, no echoes of human activity. Silence at sea is not absolute, of course. The ocean is full of sound. Waves, wind, rain, the movement of water over water. Whales and other marine animals communicate across enormous distances, using the ocean itself as a medium. Even in the most remote regions, sound travels far. But what's missing at Point Nemo is the constant low-level hum of civilization. The overlapping signals we've grown used to without realizing it. The background noise that tells us subconsciously that we are not alone. At the same time, Point Nemo is not untouched in the way we might like to imagine. Nothing on Earth truly is anymore. The currents that pass through it carry microplastics shed from products used thousands of kilometers away. Traces of industrial chemicals can be detected even there, diluted but persistent. Human influence reaches farther than human presence. And then there is what lies above it. For reasons that are practical rather than poetic, space agencies around the world have designated the ocean around Point Nemo as a preferred resting place for defunct spacecraft. When satellites and space stations reach the end of their operational lives, many are guided to re-enter the atmosphere over this region. As they burn up, fragments fall into the water below, far from shipping lanes and coastal populations. This has earned the area another unofficial name, the Spacecraft Cemetery, a place where machines that once circled the Earth at incredible speeds complete their final descent into the planet's most isolated waters. It is a strange layering of absence and accumulation, a place chosen precisely because it is empty, becoming the resting ground for objects that once represented our farthest technological reach. That contrast sits quietly beneath the surface of the idea of Point Nemo. On one hand, it is the purest expression of distance from human life. On the other, it is directly shaped by human decision-making. We avoid it, measure it, name it, and use it, all while rarely thinking about it at all. As we continue, the story of this place will widen. It will move from coordinates to currents, from isolation to ecology, from the psychology of remoteness to the quiet presence of things we leave behind. There's no need to hold on to every detail. Let the ideas drift past like clouds reflected on water. Some will catch your attention, others can pass without effort. For now, just keep in mind that somewhere out there, far beyond the edges of maps we usually care about, there is a point defined entirely by distance. A reminder that even on a crowded planet, emptiness still exists, and that sometimes the most mysterious places are not hidden, dangerous, or forbidden, but simply very, very far away. If you were to describe this place using nothing but numbers, it would sound almost disappointingly plain. A latitude, a longitude, a pair of coordinates floating quietly in the middle of the South Pacific. No dramatic names, no visual cues, no natural boundaries to hint at what makes them special. And yet, those numbers describe the most isolated surface location on Earth. Not the coldest, not the deepest, simply the farthest possible point from any land in every direction at once. The idea of loneliness usually belongs to living things, a person in an empty room, a lighthouse keeper on a distant shore, a lone tree in the desert. We don't usually apply it to coordinates, to abstract intersections of imaginary lines drawn around a spinning planet. But when people talk about the ocean's loneliest coordinates, they're not being careless with language. They're reaching for a word that captures something geometry alone cannot. Because these coordinates mark Point Nemo, the oceanic pole of inaccessibility. A phrase that sounds technical, even bureaucratic, but hides a surprisingly emotional concept. Inaccessibility here doesn't mean dangerous or blocked, it means distant, maximally distant. As far as you can possibly be from land while still standing on Earth's surface. To understand why this matters, it helps to think about how we usually relate to distance. On land, distance is broken up by landmarks. Towns, roads, forests, mountain ranges. Even when something is far away, the journey is divided into segments. There are places to stop, signs to follow, changes in scenery to reassure you that progress is happening. At sea, especially in the open ocean, distance behaves differently. There are no visual mile markers. The horizon looks the same hour after hour. Movement is felt rather than seen. Now imagine removing even the faint reassurance that land exists somewhere nearby. At Point Nemo, land is not just out of sight, it is out of practical reach. The nearest dry ground lies more than 2,600 kilometers away in every direction. That is farther than the distance between many major cities on different continents, farther than most people ever travel in their lives, and that distance exists in all directions at once. If you were floating there, suspended in calm water under a clear sky, the sense of scale would be difficult to grasp. There would be no reference points to anchor your perception, no birds flying overhead to suggest proximity to shore, no drifting debris likely to have originated nearby, just the steady motion of the ocean, rising and falling, as indifferent as it has always been. What makes this particular spot unique is not just that it is far from land, but that it is the farthest. Other remote areas exist, of course. Vast stretches of the Pacific, the Southern Ocean, parts of the Atlantic far from shipping routes. But all of those places have a direction in which land is closer. At Point Nemo, every direction leads equally nowhere. This symmetry is part of what gives the place its strange psychological weight. Humans are accustomed to orienting themselves. Even when lost, there is usually a sense that moving in one direction will eventually bring change. At Point Nemo, orientation loses meaning. North, south, east, west all lead through thousands of kilometers of open water before anything solid appears. It's worth pausing on how this was discovered because it tells us something important about modern exploration. No one sailed into Point Nemo and planted a flag. No one stood on a deck, looked around, and declared this the loneliest place on Earth. The discovery happened quietly through data. As satellite mapping improved and global coastline databases became more precise, researchers could calculate distances between every point on the ocean and the nearest landmass. This is not as simple as it sounds. Coastlines are complex, jagged, and constantly changing. Islands appear and disappear with tides and erosion. What counts as land? Does a rock breaking the surface qualify? What about ice-covered islands? These questions had to be answered carefully. Once the definitions were set, computers did the work humans never could have done by intuition alone. They searched through millions of possible points, calculating distances again and again until one location stood out. The place where the minimum distance to land was greater than anywhere else. That place received a name, almost as an afterthought, borrowed from literature rather than geography. Nemo, from Jules Verne's Captain Nemo, whose name itself means no one. There is something fitting about that. A place named for absence, discovered not by presence but by calculation. Despite how remote it is, Point Nemo does not sit above the deepest part of the ocean. The seafloor beneath it lies several thousand meters down, but not nearly as deep as the Mariana Trench or other extreme underwater features. This surprises some people, who imagine the loneliest place must also be the most dramatic. In reality, it is the opposite. The seabed there is relatively unremarkable, shaped by slow geological processes rather than sudden extremes. That ordinariness is part of the mystery. There is no single visual feature to point to and say, that's why this place matters. Its significance is relational. It exists because of everything else. Because of where the continents are not. Because of how islands are scattered across the globe. Change the positions of a few remote islands, and Point Nemo would shift. In that sense, it is a reminder that geography is not static. The coordinates are fixed for now, but over geological time they will drift. Tectonic plates move. Volcanic islands emerge and erode away. Antarctica's ice shelves advance and retreat. One day, millions of years from now, the ocean's loneliest coordinates will belong to a different place entirely. But in our time, this particular spot holds the title, and titles matter to humans, even when they describe emptiness. One of the most striking facts often mentioned about Point Nemo is that, at certain moments, the closest humans to it are not sailors or researchers, but astronauts. The International Space Station orbits Earth at an altitude of about 400 kilometers. When it passes over the South Pacific, it comes closer to Point Nemo than any settlement on land. This detail captures the imagination because it collapses two extremes: the most isolated point on Earth's surface and one of humanity's most complex machines circling above it. For a brief window, human presence exists closer in orbit than on the planet itself. It's a reminder that remoteness is not absolute. It depends on how you measure distance and from where. Yet for all its symbolic weight, almost no one has ever been there deliberately. There are no tourist expeditions, no research stations anchored nearby. The cost and effort required to reach that precise location outweigh any obvious benefits. Research vessels have limited time at sea and specific goals. Stopping at a mathematically interesting point with no unique features rarely makes the list. That absence of visitation adds to the sense that Point Nemo exists more in concept than in experience. We talk about it, we map it, we imagine it, but very few people, if any, have stood directly above it and known for certain that they were there. Even if a ship passed nearby confirming the exact coordinates amid waves and currents, would be difficult without precise instruments. And even then, what would you experience? There would be no sign, no change in the water, no shift in colour or texture. The ocean would not announce that you had arrived. You would simply be floating at another point on its surface, indistinguishable from countless others, except in terms of distance. This raises an interesting question about how humans assign meaning. If a place is significant but imperceptible, does it matter in the same way as a mountain peak or a canyon? The answer seems to be yes, but for different reasons. Point Nemo matters because it stretches our understanding of space and isolation. It forces us to think about the planet as a whole, not as a collection of familiar regions. It also highlights how thoroughly connected most of the world has become. Even remote deserts and polar regions are regularly visited by scientists, adventurers, and satellites. Communication signals blanket the planet. Shipping routes crisscross the oceans, and yet there remains a place so distant from land-based human activity that it still earns the label of loneliest. Loneliness here does not imply suffering. There is no consciousness at these coordinates to feel abandoned. But the word resonates because we project ourselves into the scenario. We imagine what it would be like to be there, to know that help is impossibly far away, that the usual safety nets do not exist. It's a thought experiment that reveals our dependence on proximity, on infrastructure, on each other. At the same time, there is something calming about that imagined isolation. No schedules to keep, no noise to escape, no expectations pressing in. Just the slow, continuous presence of the ocean, doing what it has always done. Moving heat around the planet, absorbing energy, supporting life in forms mostly unseen. Because while Point Nemo is lonely in human terms, it is not empty in a biological sense. Even in the most nutrient-poor parts of the open ocean, microscopic life persists. Plankton drift with the currents. Bacteria exist in astonishing numbers. Larger creatures pass through, following migratory routes that do not care about human definitions of remoteness. A whale swimming through those waters does not know it has crossed a boundary. A fish does not sense that land is equally distant in all directions. The ocean, to them, is continuous. This perspective gently undermines the drama we attach to the coordinates. Loneliness is a human overlay, not an inherent property of the place. Still, overlays matter. They shape how we think, what we value, what we protect or ignore. By naming the ocean's loneliest coordinates, we've created a mental landmark in a region that otherwise resists them. It becomes a reference point in conversations about isolation, about scale, about how small human presence really is when measured against the planet. And perhaps that is the quiet power of this place. It doesn't confront us with danger or beauty in an obvious way. It doesn't demand awe through spectacle. Instead, it invites a slower realization that even now, even with satellites and global networks and constant connection, there are places where human influence thins to almost nothing. Places defined not by what we've built, but by the sheer fact of distance. As this thought settles in, it naturally leads to another question. If such a place exists, how did we come to identify it in the first place? What kind of thinking, what kind of tools allow humans to measure absence with such precision? And what does that say about our relationship with the planet we inhabit? Those questions pull us gently forward, away from the coordinates themselves and toward the process that revealed them, away from the idea of loneliness as a static condition, and toward the human curiosity that insists on mapping even the most unreachable corners of the world. For most of human history, the idea of finding the middle of nowhere would have sounded like a contradiction. Exploration was driven by edges, not centres. Coastlines mattered. Islands mattered. Anything that broke the surface of the water mattered. The open ocean in between was something to cross as efficiently as possible, not something to analyse, categorise or name. Sailors did not set out looking for emptiness. They were trying to survive long enough to reach something solid. So the fact that humans eventually identified the most remote point on Earth's surface was not the result of a grand expedition or a bold voyage into uncharted waters. It was an accident of curiosity, mathematics, and a growing obsession with precision. No one woke up one morning with a burning desire to locate the loneliest place in the ocean. It emerged quietly, almost playfully, from a much more practical question. How far is everything from everything else? This kind of thinking only becomes possible once you stop seeing the world as a collection of journeys and start seeing it as a data set. For centuries, maps were approximations stitched together from travelogues, celestial navigation, and educated guesswork. Coastlines were smoothed, islands were misplaced, entire land masses appeared on charts and then vanished again when no one could find them twice. The ocean, especially the southern oceanic regions, was often left deliberately vague. Blank spaces weren't a failure of imagination, they were an admission of uncertainty. Distance in those early maps was something you felt in your body. It was measured in days at sea, in dwindling supplies, in changes in weather and morale. You knew a place was far away because getting there was exhausting or dangerous. But this kind of distance is subjective. It depends on the technology of the time, the route taken, the conditions encountered. 2 voyages covering the same stretch of ocean could feel entirely different. The shift began when distance stopped being about experience and started being about numbers. By the late 20th century, Earth was no longer just mapped, it was digitized. Satellites orbited overhead, constantly updating models of coastlines, ice sheets and islands, down to astonishing levels of detail. Computers could process geographic information in ways that would have been unimaginable to earlier generations. Suddenly the planet could be treated not just as a surface to travel across, but as a mathematical object. This is where the idea of poles of inaccessibility comes in. On land, the concept had already been explored. Researchers had calculated the point on each continent that lay farthest from any coastline. These places were interesting because they represented maximum remoteness in a very literal sense. Not difficult to reach necessarily, but far from the influence of the sea. Naturally, someone asked the inverse question: if you can find the place on land farthest from the ocean, can you find the place in the ocean farthest from land? This question did not arise from survival needs or navigation problems. Ships did not require this information. Airplanes did not care. It was a question born from completeness, from the quiet human impulse to finish the map, to fill in the conceptual gaps even when nothing practical depends on it. The person most often credited with answering that question is a Croatian-Canadian survey engineer named Hrvoje Lukatela. In the early 1990s, he used Geographic Information Systems, or GIS, to calculate the point in the ocean that lay at the greatest distance from any landmass. This required defining what counted as land, compiling global datasets, and running iterative calculations across vast numbers of possible points. The process was not glamorous. It involved algorithms, error margins, and definitions that had to be agreed upon before any result could be trusted. Tiny islands mattered. Uninhabited rocks mattered. Ice-covered land mattered. Each one slightly shifted the result. Eventually, one point consistently emerged as the answer. A location in the South Pacific, thousands of kilometers from any continent or inhabited island. A point so remote that it had no traditional name, no cultural associations, no stories attached to it at all. It needed a label, and this is where accident shades into creativity. Rather than naming it after a discoverer or assigning it a purely numerical designation, Lukatela reportedly chose the name Nemo, a reference to Captain Nemo, the fictional submarine commander from Jules Verne's novels. The name itself means no one in Latin. It fit too well to ignore. A place belonging to no one, surrounded by nothing. And just like that, the most isolated point on Earth's surface gained an identity. Point Nemo entered the lexicon not through exploration, but through calculation and literature. What's striking about this discovery is how detached it is from physical experience. Unlike mountains or trenches, which announce themselves through effort and risk, Point Nemo reveals nothing to the senses. If a ship passed directly over it without knowing the coordinates, There would be no indication that anything special had happened. The ocean would not change colour. The waves would not behave differently. The sky would not react. In that sense, humans did not so much find Point Nemo as invent it. Not in the sense that it isn't real, but in the sense that its significance exists only because we defined a rule and then followed it to its logical conclusion. The ocean did not care whether this point was identified. It existed long before and would continue to exist unchanged if the coordinates were forgotten tomorrow. This raises a subtle but important idea about modern discovery. Increasingly, we are not discovering new places by going to them. We are discovering relationships between places by analysing data. We uncover extremes, averages, boundaries, and centres not by standing there, but by comparing everything at once. In earlier eras, the unknown was dangerous. Blank spaces on maps were filled with imagined monsters or warnings. Today, the unknown is often statistical. It is something we know exists in theory but have never experienced directly. Point Nemo belongs firmly to this category. It is also a reminder of how much of our planet remains conceptually unexplored even if it is technically mapped. We know where Point Nemo is, but we do not know what it feels like to be there in any meaningful shared human sense. No community has stories passed down about it. No language has evolved words tied to that location. It has no history of human presence to anchor it in memory. And yet, once named, it begins to attract meaning. People write about it. They imagine it. They attach emotions to it. Loneliness, isolation, quiet. These are projections, but they are powerful ones. They say more about us than about the coordinates themselves. We are fascinated by places that resist us, not because they are hostile, but because they do not acknowledge us at all. There is also something telling about the timing of this discovery. The early 1990s were a moment when global connectivity was accelerating. Satellite communication, early internet infrastructure, GPS technology. The world was becoming smaller in perceptual terms. Distances that once took months to cross could now be traversed in hours. Information travelled almost instantly. Against that backdrop, identifying the most remote point on Earth carried a quiet irony. Just as humanity was knitting itself together more tightly than ever before, we paused to note that complete remoteness still existed. That even in an age of connection, there were places beyond the reach of routine human presence. The fact that this realization came through computation rather than exploration fits the era perfectly. We were no longer expanding outward geographically. We were refining inward conceptually, measuring, categorizing, optimizing. It's worth noting that the discovery was not universally treated as profound at first. In scientific terms, it was a neat result, but not a transformative one. It didn't change climate models or navigation systems. It didn't unlock new resources or solve urgent problems. It simply answered a question that had been asked because someone realised it could be answered. Over time, however, the idea gained cultural traction. Articles mentioned it as a curiosity. Documentaries referenced it as a symbol of isolation. Space agencies quietly took note for reasons that had nothing to do with poetry and everything to do with safety. The accidental discovery began to accumulate consequences. This pattern is common in science. A result that seems abstract or trivial at first gradually finds relevance as contexts shift. What begins as an answer to a hypothetical question becomes useful once someone else realises it solves a practical problem. In the case of Point Nemo, its remoteness made it ideal for something no one had been considering at the time of its naming. A place to aim falling objects from space. But before that connection fully formed, Point Nemo remained largely a conceptual landmark, a demonstration of what modern tools could do, a quiet flex of global awareness. It showed that we had reached a point where even absence could be mapped with confidence. There is also something gently humbling about how unceremonious the process was. No press conferences, no dramatic announcements, just a line of code returning a set of coordinates. In another era, such a place might have been wrapped in myth or legend. In this one, it appeared in a spreadsheet. And yet, the human response was not purely technical. The choice of name alone shows that we couldn't resist attaching story to it. We reach for fiction, for symbolism, for a character defined by separation from society. Even when discovery is accidental, meaning is not. This tension between objectivity and imagination runs through our relationship with the planet. We measure it with instruments, but we understand it through stories. We identify extremes with algorithms, then explain them with metaphors. Point Nemo sits precisely at that intersection. It exists because of math, but it resonates because of feeling. As this realization settles, another thread begins to emerge. If humans found the middle of nowhere without intending to, what else have we identified simply because our tools allowed us to notice patterns we weren't originally looking for? And how many of those discoveries quietly shape decisions far beyond their original scope? Because once you know where the most remote place on Earth is, you can't unknow it. And sooner or later, someone will ask not just where it is, but what to do with that knowledge. Human intuition is very good at many things. It helps us judge speed when crossing a road, recognize familiar faces in a crowd, and sense when something feels too quiet or too loud. But intuition begins to falter when scale stretches beyond everyday experience. Distance is one of the first concepts to slip out of reach when it grows too large, too uniform, too detached from landmarks. And nowhere does this failure of intuition become clearer than when we try to truly understand just how far away the ocean's loneliest coordinates really are. We grow up learning distance through comparison. A short walk, a long drive, a flight that takes a few hours. These are distances anchored to effort and time. You feel them in your body. Legs get tired. Attention drifts. Meals are eaten mid-journey. Distance, in this sense, is experiential. It is broken into parts that the mind can handle. But the distance surrounding Point Nemo does not behave like that. It refuses to segment itself neatly. There is no gradual approach where signs of land begin to appear. No subtle shift from far to almost there. Instead, there is an extended sameness that stretches in all directions, flattening the sense of progress until distance becomes abstract rather than felt. If someone tells you that Point Nemo is roughly 2,600 kilometers from the nearest land, the number itself is not the problem. Most people have heard numbers like that before. The problem is that the number lacks texture. It does not come with familiar cues. There is no equivalent daily experience to attach it to. It does not map cleanly onto memory. Try to imagine driving 2,600 kilometers. You might picture crossing several countries, watching landscapes change, stopping for fuel, sleeping overnight. That journey is long, but it is also varied. The mind stays engaged because the environment keeps shifting. At sea, especially in the open ocean, the same distance feels entirely different. There is nothing to break it up. The horizon remains unchanged. The water behaves the same way hour after hour. Even the sky often offers little variation. This is where intuition begins to lose its footing. Without landmarks, distance stops feeling like something you're moving through and starts feeling like something you're suspended within. Sailors have long known this effect, even if they did not describe it in mathematical terms. Long voyages across open water produce a strange distortion of perception. Days blur together. Direction becomes something you trust instruments for rather than something you feel. The sense of being far is not dramatic or frightening at first. It is quiet. It seeps in slowly, replacing urgency with a kind of mental flatness. At Point Nemo, that flatness is not a temporary phase of a journey. It is the defining condition. Another reason distance here defies intuition is symmetry. Usually when you are far from something, you're closer to something else. Move away from one city and you approach another. Leave a coastline and head toward an island. Even in deserts, distance has direction. There is usually a sense that relief lies somewhere, even if it is far off. At Point Nemo, that directional hope evaporates. Every heading is equally distant from land. There is no correct choice, no better option. This has subtle psychological consequences. The mind is wired to evaluate paths, to compare outcomes. When all options are equivalent, that evaluative machinery has nothing to work with. You're not choosing between nearer and farther. You're choosing between far and far. This is difficult to simulate mentally because it rarely happens in daily life. Even being lost usually involves gradients, a road that seems less travelled, a direction that feels more promising. Here, the gradient is flat. Distance also behaves differently when rescue is considered. In most places on Earth, remoteness still includes the possibility of response. A plane could be dispatched, a ship could be rerouted. Help is distant, but conceivable. At Point Nemo, response times stretch into uncomfortable territory. Even with modern technology, reaching that precise location would take days, possibly weeks, depending on conditions and starting point. This is not because the ocean is especially hostile there. Storms are not uniquely violent. Waves are not categorically larger than elsewhere in the South Pacific. The danger comes from logistics, not environment. Distance multiplies every problem. A small malfunction becomes serious. A minor injury becomes critical. Not because the situation itself is extreme, but because distance removes margin for error. Humans tend to underestimate this compounding effect. We think of distance as linear. Twice as far means twice as long. In reality, distance at sea often behaves exponentially in terms of risk. Supplies must last longer. Fuel calculations become tighter. Weather windows narrow. The opportunity to turn back disappears long before the destination is reached. This is one reason why Point Nemo is rarely visited intentionally. Not because it is forbidden or especially perilous, but because the payoff does not justify the exposure. There is no port to reach, no unique resource to study, no visual reward waiting at the end. You would travel an immense distance only to arrive at another patch of ocean, indistinguishable from the last. Intuition struggles with that idea as well. We expect distance to lead somewhere. We are conditioned to believe that effort results in arrival. Point Nemo breaks that narrative. It is a destination defined entirely by absence of destination. Another intuitive failure comes from how we imagine maps. On a global screen, Point Nemo looks manageable, a dot in the ocean. Zoom out far enough and everything looks close together. Continents shrink, oceans flatten. The visual compression of scale tricks the mind into thinking distances are smaller than they are. This is not just a problem of casual map reading. It is a fundamental limitation of how two-dimensional representations convey three-dimensional space. When you see the Pacific Ocean on a map, you see shape, not effort. You see area, not time. The fact that something fits comfortably on a screen says nothing about how long it would take to cross. At Point Nemo, this discrepancy becomes extreme. The map suggests emptiness, but it does not convey duration. It does not show how long the same view would repeat itself, how many hours the horizon would remain unchanged, how the sense of motion would gradually dull. Distance beyond intuition also applies vertically, in a way we rarely consider. Beneath Point Nemo lies thousands of meters of water before the seafloor appears. That depth is not record-breaking, but combined with horizontal isolation, it reinforces the sense of separation. You are not just far from land, you are far from the bottom as well. This layered distance creates a kind of isolation sandwich. Above you, empty sky. Below you, dark water. Around you, nothing to orient against. Even animals passing through would be transient. No permanent companions, no fixed reference. It is worth noting that this environment challenges not just human intuition, but also human language. We lack precise words for this kind of isolation. We borrow from emotional vocabulary: lonely, empty, remote. These words carry human feelings into a place that does not experience them. but we use them because technical descriptions fail to capture the effect on our imagination. Distance, when pushed far enough, stops being about meters and kilometers and starts being about vulnerability. This vulnerability is one reason Point Nemo often appears in thought experiments rather than travel plans. It is used to illustrate extremes, the furthest place from help, the most isolated point. These uses are not about geography so much as psychology. They test our comfort with separation. Interestingly, technology both reduces and exaggerates this discomfort. On one hand, satellite communication means a vessel at Point Nemo would not be completely silent. Signals could still be sent. Data could still flow. On the other hand, knowing that communication is possible does not eliminate physical distance. A message travelling at the speed of light does not shorten the time it takes a ship to arrive. This creates a strange split between informational closeness and physical remoteness. You could be in constant contact with people thousands of kilometres away while remaining utterly unreachable in practical terms. Intuition has trouble reconciling that. We tend to equate communication with proximity, even when the body tells a different story. Distance also distorts time perception. Long, uneventful stretches of ocean have a way of making hours feel elastic. Without changes in scenery or routine, the mind loses its usual anchors. Time can seem to slow, not because it actually does, but because memory has fewer events to mark its passage. At Point Nemo, this effect would be pronounced. Days might feel indistinguishable. The sense of moving forward could blur into simple endurance. This is not unique to that location, but the scale amplifies it. There is no anticipation of arrival to structure the experience, just continuation. This may be why the idea of Point Nemo resonates even with people who have never been to sea. It taps into a universal discomfort with unbroken distance, with stretches of life that feel directionless, with moments where effort does not lead to visible change. At the same time, there is something quietly appealing about such a place, a kind of conceptual stillness. No expectations, no obligations. Distance as a buffer rather than a threat. For some, imagining Point Nemo is calming rather than unsettling. It represents escape not through movement, but through removal. That dual reaction highlights how personal our relationship with distance really is. For some, far means freedom. For others, it means danger. Point Nemo sits neutrally between those interpretations, offering nothing to tip the balance. As we continue to think about distance beyond intuition, another realization emerges. This place challenges not just how far is far, but how we define importance. We tend to prioritize places that are connected, inhabited, productive. Distance often correlates with neglect, but Point Nemo has become significant precisely because of its distance. It is studied, referenced, and remembered not despite its remoteness, but because of it. That inversion is revealing. It suggests that even in a world focused on accessibility and efficiency, there is still value in acknowledging limits, in marking the places where connection thins to nearly nothing. And once those limits are acknowledged, they invite practical considerations. If there is a place maximally distant from land, what does that mean for objects entering the atmosphere? For debris falling back to Earth? For the things we send up and eventually must bring down? Distance, it turns out, is not just an abstract curiosity. It becomes a deciding factor, and as soon as decisions are made based on it, the middle of nowhere begins to acquire an unexpected role in human activity. An address usually implies connection. Even the most remote house still belongs to a network of roads, property lines, postal routes, and neighbouring structures. An address tells you who lives nearby, how to get there, what services reach it, and what kind of life unfolds around it. It places something within a web of relationships. But the coordinates we've been circling around resist that idea entirely. They describe a location that has no surrounding context in the way we're used to thinking about it. No streets, no borders, no neighbours at all. That's part of what makes Point Nemo feel so conceptually strange. It is an address without adjacency, a location that exists in isolation not just socially but structurally. Nothing clusters around it. Nothing radiates outward from it. It is not on the way to anywhere else. It does not benefit from proximity to anything. It simply sits, defined only by distance. To grasp why this feels so unusual, it helps to notice how deeply neighbourliness is woven into human understanding of place. We orient ourselves relationally. This cafe is next to that bookstore. This town is north of the river. This country borders that one. Even vast uninhabited regions are often described in terms of what surrounds them. A desert between mountain ranges, an ice shelf along a coast, a forest beyond a road. Remove those relationships, and something fundamental breaks. The mind searches for anchors and finds none. At Point Nemo, there is no gradual transition from busy to quiet. No fading outskirts, no thinning traffic. There is just ocean, and then more ocean, extending evenly in every direction. The nearest landmasses are not just far away, they're so distant that they do not meaningfully frame the location. Knowing their names does little to shrink the space between. This is why calling it an address feels almost ironic. Coordinates suggest precision, control, and order. They are how we tell machines where to go, how we guide planes, ships, and satellites. But here, precision leads not to usefulness, but to emptiness. The more accurately you locate Point Nemo, the more obvious its isolation becomes. In most cases, giving something an address makes it easier to reach. It integrates the location into systems of movement and communication. For Point Nemo, the opposite happens. Naming it highlights just how disconnected it is from those systems. It is reachable in theory, but profoundly impractical in reality. What's especially striking is that this isolation is not the result of barriers. There are no cliffs blocking approach, no ice walls, no political restrictions. The ocean around Point Nemo is navigable in the same way any open ocean is navigable. The isolation comes purely from scale, from the simple fact that there is a great deal of water between this point and anything else we consider significant. That kind of isolation is difficult to emotionally process because it lacks drama. There is no clear antagonist, no moment where you cross a threshold and feel cut off. Instead, the separation is diffuse. It builds quietly as distance accumulates. In social terms, neighbours serve several roles. They are points of reference, sources of help, witnesses. Even when relationships are distant or strained, the mere presence of others nearby shapes behaviour. You act differently when someone might see or hear you. You feel differently knowing someone could intervene if something went wrong. At Point Nemo, that social field collapses entirely. There is no one to notice, no one to overhear, no one to stumble upon the scene by chance. This absence magnifies the sense of vulnerability far more than physical danger would. It's not that the ocean there is especially hostile, it's that there is no redundancy, no backup, no safety in numbers. Interestingly, this kind of isolation is increasingly rare on Earth. Human activity has spread to nearly every environment. Even places without permanent settlements are routinely visited. Research stations in Antarctica, remote islands with weather sensors, deep-sea cables crisscrossing the ocean floor, aircraft passing overhead, signals bouncing through the atmosphere. Point Nemo sits at the intersection of these networks in a peculiar way. Signals pass over it, satellites orbit above it, ships skirt around it, but almost nothing stops there. It is bypassed rather than engaged. The networks acknowledge its existence without incorporating it. This makes it less like a neighbourhood and more like a gap, a hole in the mesh of human presence. And yet, the idea of neighbours does not completely vanish when you think about this place. It just shifts scale. The nearest neighbours to Point Nemo are not people or buildings, but distant islands separated by thousands of kilometres. These islands are small, often uninhabited, and functionally isolated themselves. Their existence does not mitigate the loneliness of the coordinates. If anything, it emphasises it. Even the ocean's inhabitants do not establish residency here in the way we might expect. Migratory species pass through. Fish drift with currents. Microorganisms persist everywhere. But there is no obvious ecological feature that would make this spot a gathering place. No reef, no seamount rising close to the surface, no nutrient upwelling drawing dense life. The biological neighbourhood is as sparse as the human one. This absence of clustering reinforces the sense that Point Nemo is not a destination in the usual sense. It does not attract, it does not collect, it does not concentrate activity. It exists because nothing else has claimed the space around it. There is a subtle shift that happens when you think of a place this way. Instead of asking what is there, you start asking why nothing is. And that question leads back to patterns larger than any single location. Ocean circulation, plate tectonics, the random scattering of islands across geological time. Point Nemo is not isolated because something repelled settlement or life. It is isolated because nothing happened to form nearby. No volcanic hotspot produced a chain of islands in the vicinity. No continental fragments drifted close enough. No shallow seafloor rose to break the surface. Chance, over millions of years, left a wide gap. This makes the loneliness of the place feel impersonal. It is not abandonment, it is simply non-occurrence. And yet humans are not particularly good at leaving non-occurrence alone. Once we identify a gap, we tend to fill it, if not physically then conceptually. Point Nemo becomes a reference point in discussions of remoteness, a benchmark, a comparison tool. We say something feels as isolated as Point Nemo, even if the speaker and listener have never seen the ocean, let alone that part of it. Language turns the absence into presence. Another interesting aspect of an address with no neighbours is how it challenges ownership. Most addresses imply jurisdiction. This land belongs to someone. That building falls under certain laws. Even international waters are governed by conventions and agreements. Point Nemo lies in international waters, far beyond any country's exclusive economic zone. No nation claims it. No flags fly there. No laws apply in the usual territorial sense. It belongs to everyone and no one, which in practice means it is largely ignored. This legal emptiness mirrors the physical one. There is no local authority, no governing body responsible for stewardship. That sounds liberating, but it also means neglect comes easily. When a place has no neighbours, it also has no advocates. This becomes particularly relevant when we consider what humans do with places they consider empty. Historically, emptiness has often been treated as availability. If no one lives there, if no one claims it, then it becomes a convenient dumping ground, a testing site, a sacrifice zone. Point Nemo has quietly taken on this role in one specific way. Objects falling from space are directed toward this region, precisely because there are no neighbours to endanger. No shipping lanes, no coastal communities. The address with no neighbours becomes the safest address for destruction. There is something unsettling about that logic, even if it is practical. We choose the loneliest place on Earth as the final resting place for machines that once represented our greatest technological ambitions. Space stations, satellites, cargo vehicles. They burn up in the atmosphere and scatter fragments into the ocean below. The ocean absorbs them without protest. No one watches, no one complains. The lack of neighbours becomes a feature. At the same time, this practice highlights a paradox. Point Nemo is isolated from people, but not from consequence. Materials introduced there do not remain contained. Ocean currents move. Debris sinks, corrodes, disperses. The absence of neighbours does not mean the absence of impact. It simply delays visibility. This is another way in which the idea of an address fails us. We tend to think of locations as discrete containers. Put something here, and it stays here. The ocean does not work that way. What enters it eventually spreads, even if slowly. Still, the psychological power of a neighbourless address persists. It reassures decision makers. It simplifies risk calculations. It creates a mental buffer between action and accountability. Beyond practical considerations, there is also a philosophical unease tied to places without neighbours. They confront us with the limits of social frameworks. Humans evolved in groups. Even our concepts of solitude often assume eventual return. A cabin in the woods is still connected by a road. A desert campsite is still under the same sky as distant cities. Point Nemo does not offer that comfort easily. It forces the realization that connection is not guaranteed everywhere, that the planet contains spaces where human presence thins to nearly nothing, not because it was pushed away, but because it never arrived. For some, this realization is unsettling. It highlights vulnerability. It strips away illusions of control. For others, it is oddly reassuring. It proves that the world is still larger than us, that there are places untouched by schedules, opinions, and noise. Both reactions can coexist, and neither is wrong. An address with no neighbours also invites a strange kind of introspection. When there is nothing around to respond to you, attention turns inward. The environment offers no feedback, no distractions, no social mirrors. You're left with your own thoughts, magnified by silence and scale. This is one reason extended isolation, even in relatively safe environments, can be psychologically challenging. The absence of others removes subtle cues that regulate behaviour and emotion. Time stretches, priorities blur, internal narratives grow louder. Imagining oneself at Point Nemo often triggers this line of thinking. What would it feel like to be there, knowing no one is nearby? Would it be peaceful or oppressive? Liberating or frightening? The answer depends less on the location and more on the person imagining it. That variability is telling. Point Nemo functions as a psychological mirror as much as a geographic one. It reflects our comfort or discomfort with solitude, with insignificance, with the idea that some places exist entirely outside human concern. And yet, the moment we think about it this deeply, we're already making it less neighbourless. We're giving it attention, memory, narrative. In a sense, we become its neighbours from afar. This is perhaps the final irony. The address with no neighbours accumulates them in thought. Writers, scientists, viewers, listeners, all orbiting the idea without ever arriving. The place remains physically untouched while becoming conceptually crowded. As that realization settles, another thread begins to pull at the edges of the story. If this place has no neighbours on the surface, what lies beneath it? What kind of landscape exists below the water, hidden from view, shaping currents and life in ways we rarely consider? Because even in the loneliest address on Earth, the surface is only part of the picture. From the surface, the ocean above Point Nemo gives nothing away. The water does not signal what lies beneath it. It does not grow darker in a meaningful way, or calmer, or more restless. Waves behave according to wind and weather, not geology. To a ship passing overhead, the ocean looks like ocean anywhere else in the open Pacific. Flat horizons, repeating swells, a skin of moving water with no visible hint of the terrain far below. But beneath that surface exists a landscape as foreign as anything humans have ever imagined, shaped not by weather or sunlight, but by time, pressure, and forces that operate far outside everyday experience. It is easy to forget that the ocean is not just deep, but layered. The water above Point Nemo stretches downward for several kilometers before it ever touches solid ground. And that ground, when it finally appears, does not resemble land as we know it. The seafloor here is part of the abyssal plain, a vast underwater region that covers much of the Earth's surface, yet remains largely unseen and poorly understood. Unlike dramatic underwater features such as mid-ocean ridges or trenches, abyssal plains are deceptively subtle. They're relatively flat, gently sloping expanses of sediment, formed over millions of years as fine particles settle slowly from above. This flatness is not emptiness, it is accumulation. A slow rain of organic matter, microscopic shells, mineral dust and volcanic ash drifting down through the water column. Each particle falls at its own pace, taking years, sometimes centuries, to reach the bottom. Over geological time, these particles build thick blankets of sediment, smoothing out older features, burying ridges and scars beneath layers of quiet deposition. The distance involved in this vertical journey is as difficult to intuit as the horizontal isolation of the surface. Sunlight penetrates only the uppermost layers of the ocean. By the time you reach a few hundred meters down, light fades into dim blues. Go deeper still, and darkness becomes complete. At the depths beneath Point Nemo, there is no light at all. None. Not even the faint glow that some deep-sea creatures use to communicate. This absence of light fundamentally changes how landscapes exist. On land, terrain is defined visually. Mountains rise because we see them. Valleys cut downward because we recognize their shape. Under the ocean at this depth, shape is something inferred through instruments, not experienced directly. Sonar maps reveal contours. Remote vehicles send back images illuminated by artificial light. Without these tools, the seafloor would remain a purely theoretical surface. And yet, despite its remoteness, this alien landscape is not static. It is shaped by forces that continue to operate slowly but relentlessly. Tectonic plates shift beneath the sediment. Heat flows upward from the Earth's interior. Occasionally, earthquakes ripple through the crust, rearranging structures that will not be seen for thousands of years. Beneath Point Nemo, the seafloor is old, very old. The Pacific Plate, which dominates this region, is one of the largest and oldest tectonic plates on Earth. As it moves slowly northwestward, it carries this patch of ocean floor away from the mid-ocean ridge where it was originally formed. Over tens of millions of years, it cools, thickens, and sinks slightly, increasing the depth of the water above it. This gradual sinking contributes to the extreme depth of the ocean here, not because the seafloor drops suddenly, but because it has had so much time to settle. Time, in this environment, is the dominant sculptor. Nothing happens quickly. Even dramatic events like volcanic eruptions or tectonic shifts are rare on human timescales. Volcanic activity does exist in the broader region, though not directly beneath Point Nemo. Hotspots elsewhere in the Pacific have produced island chains, some of which now rise above the surface while others remain submerged. But near this particular point, no hotspot has passed beneath the plate recently enough to create a seamount or island. The absence of such features contributes to the uniformity of the sea floor. That uniformity is deceptive. On smaller scales, the bottom is textured with ripples, mounds, and depressions formed by slow-moving currents and the activities of organisms. Burrowing creatures rework the sediment, mixing layers and redistributing nutrients. Even in complete darkness, life modifies the landscape. This is one of the most counterintuitive aspects of the deep ocean. The idea that life persists, adapts, and even thrives in such extreme isolation challenges surface-based assumptions. Without sunlight, ecosystems must rely on different energy sources. Organic material sinking from above becomes precious fuel. Chemical gradients near the sea floor support specialized forms of life that do not depend on photosynthesis at all. At Point Nemo, biological productivity is relatively low compared to coastal regions or upwelling zones. The waters above are often described as oligotrophic, meaning nutrient poor. There are fewer phytoplankton blooms, less food rains down to the depths. As a result, life is sparse, slow-growing, and highly efficient. Creatures here are adapted to scarcity. They conserve energy. They move slowly. They reproduce infrequently. Many have soft bodies, reduced skeletons, and metabolic rates tuned to a world where meals are unpredictable and patience is essential. The landscape they inhabit reflects these conditions. There are no coral reefs, no towering kelp forests, no dramatic underwater cliffs. Instead, there is a muted, subdued terrain. Soft sediment punctuated by the occasional rock, tracks left by organisms moving across the bottom, sometimes preserved for years because there is so little disturbance. Pressure adds another layer of alienness. At depths of several kilometres, pressure reaches hundreds of times that at the surface. Every square centimetre of an organism's body is compressed by the weight of the water above. Structures that would collapse on land function normally here. Materials behave differently. Chemistry itself changes under these conditions. This pressure, combined with cold temperatures just above freezing, creates an environment utterly hostile to surface life forms. Humans cannot survive there without heavily engineered protection. Even machines struggle. Electronics must be shielded. Materials must be chosen carefully to avoid crushing or corrosion. The seafloor beneath Point Nemo has been visited far less often than the surface of the moon. This is not an exaggeration. The technical difficulty and cost of deep-sea exploration limit how often researchers can send vehicles to such depths. When they do, missions are carefully planned and brief. Every minute of footage is valuable. What we know of this alien landscape comes in fragments. Sonar maps showing broad shapes, grainy video of sediment clouds stirred by robotic arms, samples brought back and analysed in laboratories far from the ocean. Each piece adds to a picture that remains incomplete. And yet, even this incomplete picture reveals something important. The seafloor beneath Point Nemo is not special because of dramatic features. It is special because of continuity. It represents the vast, unbroken expanses that make up most of the ocean floor, the parts that are not named, not visited, not romanticised. This challenges another human tendency. We gravitate toward extremes, the deepest trench, the tallest ridge, the most active vent. But the ocean is mostly not those things. It is mostly plains, quiet, ancient, slowly changing. The alien landscape beneath Point Nemo is a reminder of that truth. It also reframes how we think about isolation. From the surface, Point Nemo feels lonely because of its distance from land and people. From the perspective of the sea floor, isolation has a different meaning. There, isolation is normal. There are no continents nearby, no shores. The deep ocean is one continuous environment, connected across basins by currents and geological history. In that sense, the seafloor beneath Point Nemo is not isolated at all. It is part of a global system. Water masses formed near Antarctica flow through these depths. Sediments carry chemical signatures from distant regions. Even life forms may share ancestry with organisms thousands of kilometres away, spread slowly by currents over evolutionary timescales. This layered perspective complicates the idea of loneliness. What feels isolated at one scale may be deeply connected at another. The surface coordinates mark maximum distance from land, but below, the landscape belongs to something larger and older than human maps. Still, the alienness remains. Not because it is disconnected, but because it operates under rules we do not live by. Time stretches, light disappears, pressure dominates, energy is scarce. The rhythms of life slow to a pace that feels almost static from a human viewpoint. Imagining this landscape beneath the quiet surface adds depth, literally and figuratively, to the idea of Point Nemo. It is not just a point floating on water. It is a column of space extending from the sky, down through kilometres of ocean, to a seafloor shaped by forces indifferent to human presence. And as we hold that image, water layered above an unseen world, another question begins to take shape. If life can persist even here, in such isolation and scarcity, what forms does it take? What strategies allow organisms to survive where distance and darkness dominate everything? Because even above an alien landscape, the ocean is never truly empty. It's tempting to imagine the ocean around Point Nemo as sterile, a watery desert where nothing meaningful survives. Distance encourages that assumption. So does darkness. So does the absence of visible activity. When humans picture life, we tend to picture density. Forests thick with leaves, reefs crowded with colour, cities teeming with motion. We associate thriving with abundance and proximity. By that logic, a place defined by isolation and scarcity should be nearly lifeless. And yet the ocean has a long history of quietly disproving our assumptions. Life does exist here, not dramatically, not loudly, but persistently, patiently, in forms so adapted to constraint that survival itself becomes almost invisible. To understand how life thrives where almost nothing should, it helps to let go of surface expectations and shift perspective toward efficiency rather than abundance. The waters above Point Nemo are classified as oligotrophic, meaning they contain very low concentrations of nutrients. Sunlight reaches the surface layers, but there is little to fuel large phytoplankton blooms. Without those blooms, the foundation of the marine food web remains thin. Less energy enters the system at the top, and everything below must adapt accordingly. In coastal regions, nutrients are replenished constantly. Rivers carry minerals from land. Winds drive upwelling currents that pull nutrient-rich water from the depths. In the open ocean, far from continents, these mechanisms weaken. At Point Nemo, they are almost absent. The water is clear, blue, and biologically quiet. That quiet, however, is not emptiness, it is restraint. Phytoplankton still exist here, but in low numbers. They are smaller, slower growing, and highly specialized. Instead of explosive blooms, they persist at steady, minimal levels. They capture sunlight efficiently, extract what little nutrition is available, and reproduce cautiously. Their goal is not expansion, it is continuity. These microscopic organisms form the base of the local ecosystem, sparse as it is. Above them exists zooplankton, equally adapted to scarcity. Many drift rather than swim, conserving energy. Some migrate vertically each day, rising toward the surface at night to feed and sinking back into deeper, darker layers during the day to avoid predators. This daily movement, repeated across the open ocean, is one of the largest migrations on Earth by biomass, even in places as remote as this. Higher up the food chain, life becomes increasingly transient. Fish pass through rather than settle. They follow temperature gradients, current systems, and prey distributions that shift over time. There is no reason to linger in one spot when food is unpredictable and widely dispersed. Larger animals, such as whales, may cross these waters during long migrations. To them, Point Nemo is not a destination. It is a segment of a much longer journey. They do not perceive the isolation in the same way humans do. Their maps are internal, guided by memory, magnetic fields, and instinctive responses to the ocean structure. But perhaps the most remarkable life associated with this place exists far below, closer to the sea floor. Here, sunlight is absent, temperatures hover near freezing, and food arrives only as a slow drizzle of organic matter sinking from above. This material, often called marine snow, consists of dead plankton, fecal pellets, and other biological debris. It falls continuously, but sparsely. In nutrient-rich regions, marine snow can be abundant enough to support relatively active communities on the seafloor. At Point Nemo, the snowfall is light. Life there must make do with very little. Organisms grow slowly. Some take decades to reach maturity. Others may live far longer than similar species in shallower waters, precisely because their metabolism is so reduced. Many deep-sea creatures exhibit adaptations that seem almost counterintuitive to surface dwellers. Soft bodies reduce energy costs. Minimal musculature reflects a world where sudden movement is rarely advantageous. Some species have transparent tissues, making them nearly invisible in the darkness. Others have oversized sensory organs to detect faint chemical signals or vibrations. Bioluminescence appears in some species, though less commonly than in more productive deep-sea regions. Light, when used here, is not for spectacle. It is for efficiency. A brief flash to attract a mate, a subtle glow to lure prey. Energy is not wasted. There are also organisms that blur the line between life and environment. Microbial communities inhabit sediments, extracting energy from chemical reactions rather than organic food. They metabolize compounds such as methane or sulfur, processes that do not depend on sunlight at all. These microbes form the foundation of ecosystems that operate independently of the surface world. What's striking is that many of these organisms are not unique to Point Nemo. Similar life forms exist throughout the deep ocean. The difference here is density, not novelty. Everything is thinner, more spread out, less likely to encounter another organism by chance. This scarcity reshapes interactions. Predation is rarer. Competition is muted. Encounters are less frequent but potentially more consequential. When food is scarce, missing an opportunity can be costly. When mates are rare, finding one becomes a significant challenge. Some species address this by being opportunistic. They eat whatever arrives. Others by being extremely patient, waiting long periods between meals. Some have evolved to reproduce in ways that increase the chances of success despite low encounter rates, such as releasing large numbers of gametes into the water column and trusting currents to do the rest. From a human perspective, this kind of life can seem precarious, but it has endured for millions of years. Scarcity is not new to the deep ocean, it is the default condition. Life did not adapt to abundance and then retreat. It evolved under constraint from the beginning. This is an important corrective to how we often think about thriving. We equate thriving with visible success, with growth and expansion. In reality, thriving can mean persistence. It can mean maintaining balance under harsh conditions without collapse. By that measure, life at Point Nemo is not struggling. It is doing exactly what it has evolved to do. There is also a quiet resilience here that is easy to overlook. Even though productivity is low, the ecosystem is stable. There are no sudden booms and busts, no seasonal cycles driven by monsoons or river discharge. Conditions change slowly, and life responds slowly in turn. This stability has a downside. Slow-growing, long-lived organisms are often less able to recover from disturbance. If something disrupts the system, it may take decades or centuries to return to its previous state. That makes the apparent emptiness of the region deceptive. It is not empty in the sense of being expendable. It is delicate in a way that does not announce itself. Human influence, though minimal in terms of direct presence, still reaches this ecosystem. Pollutants travel long distances. Microplastics have been detected even in remote ocean gyres. Chemical traces from industrial activity can be found far from their sources. Life here must contend with these intrusions without the buffering effect of high productivity. Then there is the matter of falling debris from space. While most objects burn up during re-entry, some fragments may reach the ocean's surface and sink. Over time, these materials become part of the seafloor environment. The quantities involved are small relative to the size of the ocean, but in a region where change is slow, even small additions matter. This raises questions about what it means to designate a place as empty. Emptiness often invites use without consideration. But the presence of life, even sparse life, complicates that narrative. It challenges the idea that remoteness equals insignificance. There is also a philosophical dimension to life thriving here. It reminds us that life does not require comfort. It does not require visibility. It does not require meaning in a human sense. It requires only the conditions necessary to continue chemical processes that sustain organization over time. That realization can be unsettling or reassuring depending on how you frame it. On one hand, it underscores how indifferent life can be to our values. On the other, it suggests a robustness that extends far beyond familiar environments. Thinking about life at Point Nemo also invites a comparison with space. We often look to Mars or icy moons for signs of life under extreme conditions. Meanwhile, beneath our own oceans exist environments just as alien, just as challenging, yet undeniably alive. The difference is not difficulty, but attention. We rarely romanticize these deep, sparse ecosystems because they resist spectacle. There are no vivid colours or dramatic behaviours to capture easily. Their beauty lies in subtlety and endurance, in the fact that life, given even the smallest foothold, finds a way to persist, and perhaps that persistence is the quiet heart of the mystery. A place defined by maximum distance from land still supports life, not in spite of isolation, but within it. The same currents that isolate the region also connect it to the rest of the ocean over long timescales. The same scarcity that limits growth also stabilizes the system. As this understanding settles, it reframes the idea of Point Nemo yet again. It is not just lonely or remote. It is functional, integrated, alive in its own restrained way. And that leads naturally to another consideration. If life exists here without relying on proximity to land or human activity, what does the absence of human signals, noise, and interference mean for this environment? How quiet is quiet, really, in the middle of the ocean? Because isolation is not only measured in distance, but also in sound. Silence is rarely absolute. Even in places we describe as quiet, there is usually a background presence of sound, a hum so familiar we stop noticing it. Wind in trees, distant traffic, electrical systems working behind walls. On land, silence is often an illusion created by distance rather than true absence. The ocean complicates this further, because water carries sound far more efficiently than air. What feels remote on the surface can still be acoustically crowded beneath it. And yet, in the vast expanse surrounding Point Nemo, something unusual happens. Not complete silence, but a thinning of signals so profound that it alters how sound, communication and awareness function altogether. This is one of the least visible yet most striking aspects of the region. The absence of signals does not announce itself loudly. It reveals itself slowly through what you do not hear. To understand why this matters, it helps to reconsider how sound behaves in the ocean. Water is an excellent medium for transmitting acoustic energy. Low-frequency sounds, in particular, can travel thousands of kilometers with relatively little loss. This is why whales can communicate across ocean basins, and why submarines rely on sonar rather than sight. The ocean is not just filled with sound, it is structured by it. Human activity has added an enormous amount of noise to this system. Commercial shipping produces constant low-frequency hums that propagate across entire regions. Naval sonar pulses cut through the depths with startling intensity. Seismic surveys for oil and gas exploration generate repetitive acoustic blasts. Even weather contributes. Rain striking the surface creates a distinctive soundscape that filters downward. In most parts of the ocean, these sounds overlap and accumulate. The result is a persistent acoustic fog. It never fully stops. It ebbs and flows, but it rarely disappears. Marine animals have adapted to this noise in various ways, but the overall soundscape has changed dramatically in the past century. Point Nemo stands apart from this pattern not because sound cannot reach it, but because fewer sources exist nearby. There are no shipping lanes crossing directly overhead, no ports sending constant traffic outward, no coastal cities contributing to the acoustic clutter. The usual background of human-generated noise thins out. This does not mean the region is silent. Natural sounds remain. Waves breaking at the surface, wind passing across the water, the subtle crackling created by microscopic organisms, the occasional call of a passing whale. But the density of overlapping signals is lower. The pauses between sounds grow longer. In this environment, stillness becomes perceptible not as an absence, but as space between events. For marine life, this acoustic clarity can matter deeply. Many species rely on sound more than sight. In darkness, sound becomes the primary sense. It conveys information about prey, predators, and the environment itself. When noise levels are low, these signals stand out more clearly. Communication becomes more efficient. Orientation becomes easier. There is evidence that some marine mammals prefer quieter regions when possible, not because they seek isolation in a human sense, but because noise interferes with essential behaviours. Echolocation clicks bounce back with more reliable information. Social calls carry farther without distortion. At Point Nemo, the reduced presence of anthropogenic noise may create a rare acoustic refuge, not pristine in an absolute sense, but closer to the baseline conditions that existed before widespread industrial activity. This makes the region interesting to researchers studying how soundscapes influence marine ecosystems. Stillness also applies to physical movement in subtle ways. The open ocean is never motionless, but certain areas experience less variability. Major currents bypass Point Nemo rather than converging there. There is no strong upwelling to churn nutrients upward. Surface conditions can remain stable for long periods. This stability contributes to the sense of suspension. The water moves, but it does not rush. It circulates slowly, part of global patterns that operate on timescales far longer than storms or seasons. From the perspective of a drifting organism, the environment changes gradually, almost imperceptibly. For humans, imagining this stillness can be unsettling because we associate lack of change with stagnation. But in the ocean, slow change is not failure. It is equilibrium. The system maintains itself through consistency rather than fluctuation. The absence of signals extends beyond sound. Radio communication, for example, becomes less reliable the farther one moves from infrastructure. While satellites provide coverage across the globe, many traditional maritime communication systems rely on proximity to land-based transmitters. At Point Nemo, reliance on satellite links becomes absolute. Even visual signals are rare. No navigation lights. No aircraft contrails most of the time. No reflections from distant structures at night. The sky remains largely unmarked by human activity. Stars appear sharper. The Milky Way becomes more prominent, weather permitting. Artificial light pollution drops to nearly zero. This visual quiet has psychological effects. Humans evolved under dark skies, but most modern lives unfold under constant illumination. Darkness, when it is deep and uninterrupted, can feel unfamiliar. It removes cues that normally anchor perception. Without lights on the horizon, distance becomes harder to judge. Scale becomes ambiguous. In such conditions, the boundary between sky and ocean can blur. At night, the horizon dissolves. You're left with darkness above and darkness below, separated only by subtle changes in texture. This can induce a sense of floating rather than standing, of being held in place by the environment rather than moving through it. Signals also include less obvious forms of information. Chemical signals in the water, for instance, disperse differently in calm, low-activity regions. Scent trails used by some organisms persist longer when turbulence is low. At Point Nemo, this can increase the effectiveness of chemical communication, even as encounter rates remain low. Electromagnetic signals behave differently as well. While the Earth's magnetic field is present everywhere, local disturbances caused by infrastructure or geology are minimal here. Some animals use magnetic cues for navigation. In a region with fewer anomalies, those cues may be clearer, though this remains an area of active research. For humans, the absence of signals often translates into a feeling of disconnection. We are accustomed to constant feedback. Notifications, updates, a steady stream of information confirming that the world is still responding to us. Remove that stream, and the mind reacts. Some experience relief, others experience unease. Without signals, the passage of time feels different. Minutes stretch, attention turns inward. Thoughts loop or slow. The environment stops prompting reaction, and instead becomes a backdrop for introspection. This reaction has been documented in environments far less remote than Point Nemo, polar research stations, long ocean crossings, space missions. In each case, the reduction of sensory input and social feedback alters cognition. Focus sharpens in some areas and dulls in others. Emotional responses can intensify or flatten. Point Nemo represents an extreme case of this effect, even if only imagined. It strips away not just human presence, but the subtle traces of that presence that usually persist even in remote places. It offers a reminder that much of what we perceive as normal background is actually constructed. The absence of signals also affects how emergencies are perceived. In populated areas, unusual silence often signals trouble, a power outage, a system failure. In the open ocean, silence is the default. Distinguishing between normal and abnormal becomes harder without reference points. This complicates response strategies. Automated systems can monitor and transmit data, but human intuition struggles without familiar cues. A quiet engine noise, a missing radio call. These absences mean different things in different contexts. At Point Nemo, absence is not immediately diagnostic. This has practical implications for navigation and safety. It demands greater reliance on instruments and protocols. There is less room for improvisation based on environmental feedback. The environment does not communicate clearly in human terms, and yet, this very absence of signals is what makes the place appealing for certain uses. The lack of shipping traffic reduces collision risk. The acoustic quiet minimizes interference. The remoteness lowers the chance of unintended encounters. These factors converge to make the region useful precisely because it is empty. Stillness becomes utility, but utility does not erase consequence. Just because signals are absent does not mean actions go unnoticed forever. The ocean records disturbances differently. Sound waves dissipate, but physical changes persist. Materials introduced sink, corrode, integrate. The quiet surface hides slow transformations below. There is also a cultural aspect to silence worth considering. Silence is often romanticized as peaceful, but it can also represent neglect. Places without signals are easy to overlook, easy to exclude from decision-making. When something goes wrong there, it takes longer to be noticed. Point Nemo's silence thus carries a double meaning. It is both refuge and blind spot, a place where the absence of interference creates clarity, and a place where absence of attention allows activities to occur with minimal scrutiny. This duality mirrors broader patterns in how humans treat remote environments. We value them for their emptiness while simultaneously exploiting that emptiness. We appreciate their quiet while contributing to changes that remain unheard. Thinking about silence in this context invites a more nuanced understanding. Silence is not just lack of sound, it is lack of feedback, lack of friction, lack of witnesses, and those conditions shape behaviour whether we acknowledge it or not. For marine life, reduced noise can be beneficial. For humans, reduced oversight can be tempting. These opposing effects coexist in the same space, layered like the water itself. As attention lingers on this idea, it naturally drifts toward a question of intent. If this place is so quiet, so empty of signals, why has it been deliberately chosen for certain human activities? Why direct objects there? Why involve this remote region in our technological cycles at all? Because silence, stillness, and absence do not just describe a condition, they create opportunity. When humans send objects into space, there is an unspoken assumption that the story ends when the mission does. A satellite stops transmitting. A cargo vehicle completes its final task. A space station is decommissioned. The machinery has fulfilled its purpose, and attention shifts elsewhere. But nothing launched into orbit can simply be forgotten. Gravity ensures that every object sent upward will eventually come back down. The question has never been whether these objects return, but where. As space activity increased through the late 20th century, this question grew from a theoretical concern into a logistical necessity. Thousands of satellites began circling the Earth. Large structures assembled piece by piece in orbit. Human presence in space became routine rather than exceptional. With that routine came responsibility. Defunct hardware could not be allowed to re-enter the atmosphere at random. Re-entry is violent. As spacecraft descend, friction with the atmosphere generates intense heat. Many components burn up entirely, but not all. Larger or denser fragments can survive long enough to reach the surface. Predicting exactly what survives and where it falls involves uncertainty. Even with careful modelling, margins of error remain. Dropping debris over populated areas was not an option. Not ethically, not politically, not practically. The solution had to minimise risk to people, infrastructure and active shipping routes, and that requirement narrowed the map quickly. Oceans became the obvious answer. They cover most of the planet. They absorb impact. They are sparsely populated compared to land. But not all ocean regions are equally suitable. Shipping lanes crisscross much of the sea. Fishing fleets work vast areas. Submarine cables and sensitive ecosystems complicate others. What space agencies needed was not just water, but emptiness. That search inevitably led to Point Nemo. This region offered a rare combination of factors: extreme distance from land, minimal ship traffic, low likelihood of fishing activity, no nearby coastal populations. The same characteristics that made it feel abstract and lonely also made it statistically safe. The decision was not driven by mystery or symbolism. It was driven by risk assessment. When planners consider controlled re-entry, they calculate corridors rather than points. A spacecraft is guided into the atmosphere along a predicted path. Even small variations in angle, atmospheric density, or structural breakup can spread debris over a wide area. The goal is to ensure that this debris footprint lies entirely over open water, with as much buffer as possible. The region around Point Nemo provides that buffer. Even if predictions are imperfect, the probability of debris intersecting human activity remains extremely low. In practical terms, it is the safest place on Earth to let something fall from space. This logic first gained prominence during the era of large orbital structures. Smaller satellites often burn up completely. Larger spacecraft do not. Space stations, in particular, contain components designed to withstand extreme conditions. Letting such structures decay uncontrolled was unacceptable. As a result, agencies began planning deliberate deorbits. The idea was not new, but the scale was. These were not single objects. They were massive, complex assemblies, sometimes weighing tens or hundreds of tons. Bringing them down safely required precision and a destination that could tolerate error. Point Nemo became that destination. Over time, dozens of spacecraft have been directed toward this region. Cargo vehicles after resupplying orbital stations, defunct satellites, experimental platforms. The most famous planned descent involved the Russian Mir space station in 2001. Once a symbol of long-duration human presence in orbit, Mir was intentionally guided into the atmosphere, breaking apart over the South Pacific. Fragments splashed down far from land, unseen by anyone except tracking systems. Later, other vehicles followed. This has led to an unusual accumulation of human-made objects on the seafloor beneath and around Point Nemo, not in the sense of a visible junkyard, but as scattered remnants, widely dispersed, slowly sinking through kilometres of water. Each object arrives stripped of context. A piece of metal here, a fragment of insulation there, all settling into sediment that moves on timescales far beyond human concern. The idea of a spacecraft cemetery sounds dramatic, but the reality is quiet. There are no markers, no fences, no sense of finality. The ocean does not acknowledge these arrivals. It absorbs them, corrodes them, and eventually incorporates them into its chemistry. From a human standpoint, the choice makes sense. It minimizes immediate harm. It reflects responsible planning within the constraints of current technology. But it also reveals something about how we treat places we consider empty. We're comfortable using emptiness as a solution. This is not unique to space activity. Throughout history, remote regions have been used as testing grounds, dumping sites, and sacrificial zones. Deserts for nuclear tests, remote islands for experiments, deep oceans for waste disposal proposals, distance creates a sense of moral insulation. If no one is there to be affected, the action feels cleaner. Point Nemo fits this pattern, even if the scale and impact are very different. The debris involved is limited, the risk is managed. The intent is not disposal of waste in the traditional sense, but controlled end-of-life handling of complex machines. Still, the underlying logic remains. This place is chosen because it is far from scrutiny. That scrutiny matters because the absence of neighbours does not mean absence of consequence. Materials introduced into the ocean eventually interact with biological and chemical systems. Metals corrode, coatings degrade, trace elements leach out. In a high-energy, productive environment, these effects might be diluted quickly. In a slow, sparse system, they persist longer. This does not mean the region is being poisoned or overwhelmed. The scale of input is small relative to the size of the ocean, but it does mean the designation of a place as safe for impact often focuses on human safety rather than ecological subtlety. Space agencies are aware of this. Environmental impact assessments are conducted. Materials are chosen to minimize harm. Controlled re-entry ensures most mass burns up before reaching the surface. What remains is spread over a wide area. From an engineering perspective, the solution is elegant. From an ethical perspective, it raises questions that do not have easy answers. Why do we assume that remoteness equals acceptability? Is absence of human presence sufficient justification? Or should ecological invisibility be treated with the same care as populated environments? These questions become more pressing as space activity increases. The number of satellites in orbit continues to grow. Mega constellations promise global coverage. Space tourism expands. Each object launched represents a future re-entry event, planned or unplanned. The middle of nowhere begins to carry more weight. There is also a symbolic dimension that cannot be ignored. Space represents aspiration, exploration, the extension of human presence beyond Earth. Bringing those machines back down into the planet's most isolated waters feels like a reversal, a return not to civilization, but to silence. It highlights a boundary we have not crossed. We can orbit Earth. We can leave it briefly, but we remain bound to it. Everything we send up must eventually come home, and when it does, we choose where it lands. Choosing Point Nemo is a reminder that our technological reach has outpaced our emotional engagement with the planet's emptiest places. We treat them as blank canvases because they do not push back, yet the ocean does not forget. It records differently, in layers, in chemistry, in slow biological response. This does not mean the decision to use Point Nemo is wrong. It means it is revealing. It shows how modern decision-making balances safety, efficiency, and visibility. It shows what we prioritize when forced to choose, and it shows that even the most remote place on Earth is not untouched by our ambitions. Distance delays consequence. It does not eliminate it. As more objects are guided toward this region, the story of Point Nemo becomes less about pure isolation and more about quiet accumulation. Not of people or buildings, but of history. A record of missions completed, technologies retired, chapters of exploration closed without ceremony. This accumulation invites another layer of reflection. If machines fall here because no one lives nearby, what happens when we start paying attention? When the idea of this place enters public awareness not just as a curiosity, but as a functional component of our space infrastructure? Because attention changes how emptiness is perceived, and once a place is no longer invisible, it stops being neutral. That shift in perception leads naturally to another question. If objects fall from the sky here, what exactly happens to them? How do they move from orbit to ocean floor? And what remains once the fire and impact are over? Because the journey downward is as complex and consequential as the journey up. When something falls from the sky, we tend to imagine a straight line. An object losing height, accelerating downward, striking the ground with force. It's a simple picture, rooted in everyday experience, drop a stone, watch it fall. But the objects that return to Earth from orbit do not behave that way at all. Their descent is stretched across thousands of kilometers, shaped by speed, heat, fragmentation, and chance. By the time anything reaches the ocean near Point Nemo, the journey has already rewritten what falling means. To understand what actually happens, it helps to begin far above the atmosphere, where falling does not feel like falling at all. Objects in orbit are not hovering. They are moving sideways at extraordinary speeds, fast enough that as they fall toward Earth, the planet curves away beneath them. This balance between forward motion and gravitational pull is what keeps satellites aloft. When that balance is disturbed, when an object slows down or is deliberately redirected, orbit begins to decay. Decay is not sudden. It can take days, weeks, or years depending on altitude and atmospheric drag. Even at the edge of space, traces of atmosphere exist. Molecules brush against orbiting objects, stealing tiny amounts of energy. Over time, this drag lowers the orbit until the object begins to encounter denser layers of air. This is where falling truly begins, but not in the way intuition expects. As a spacecraft plunges into the upper atmosphere, it is still moving horizontally at several kilometers per second. The air in front of it cannot move out of the way quickly enough. It compresses, heats up, and forms a shock wave. Temperatures soar to thousands of degrees. This heat does not come from friction in the everyday sense, but from compression. The atmosphere itself becomes incandescent. Most satellites are not designed to survive this. Thin panels, delicate electronics, lightweight structures. They break apart quickly, disintegrating into plasma and vapor. From the ground, if visible at all, this process appears as a streak of light, a brief artificial meteor. Larger objects behave differently. Spacecraft designed for human use or long-duration missions are built more robustly. Thicker walls, denser materials, redundancies. As they encounter heat and stress, they fragment, but not all at once. Pieces peel away, each following its own path, each experiencing its own heating profile. This fragmentation turns a single object into a cloud of debris, spreading out over hundreds or thousands of kilometers. Some fragments burn up entirely, others survive long enough to slow down, cool, and continue descending as solid objects. By the time anything reaches lower altitudes, the violence has already occurred. What remains is no longer a spacecraft in any recognizable sense. It is debris, twisted metal, charred components, objects stripped of function and meaning. Where these fragments land depends on many variables: entry angle, speed, atmospheric conditions, structural breakup sequence. Even small uncertainties can shift the debris footprint dramatically. This is why controlled re-entry aims not for precision impact points, but for corridors. Long, empty swathes where error margins remain acceptable. The ocean near Point Nemo sits squarely within such corridors. When debris reaches the lower atmosphere above this region, there are no cities beneath it, no roads, no farms, no clusters of human activity. The final descent may take minutes or hours depending on the fragment. Some pieces fall almost vertically, others glide, tumble, or flutter. Eventually gravity wins completely. The fragments strike the ocean. The impact itself is often anticlimactic. At terminal velocity, many pieces hit the water with force but not explosively. The ocean surface breaks. A splash forms. Water closes again. Waves radiate outward and quickly dissipate. There is no crater, no scar. The ocean leaves no lasting surface trace. For heavier fragments, the journey continues downward. Water slows them rapidly compared to air. Momentum bleeds away. Some pieces tumble and settle gently. Others plunge deeper before decelerating. Currents nudge them sideways as they fall, altering their final resting place. The seafloor beneath this region is deep enough that it may take hours for debris to reach it. During that descent, fragments pass through layers of water with different temperatures, densities, and chemical properties. Marine snow accumulates on surfaces almost immediately. Microorganisms begin to colonize exposed materials. By the time an object reaches the bottom, it is already part of the ocean. This process has repeated dozens of times over the past few decades. Each event adds a small number of objects to a very large environment. There is no pile-up in the usual sense. Debris is scattered across wide areas. Some pieces sink into soft sediment and disappear from view. Others rest exposed, gradually corroding. From above, nothing marks these sites. Satellites cannot see them. Ships passing overhead would have no indication that anything lies below. The ocean surface remains indifferent. What makes this phenomenon unsettling for some is not the physical impact, but the invisibility of it. On land, falling objects demand attention. They leave marks. They prompt investigation. At sea, especially in remote regions, events can occur without witnesses or memory. This invisibility creates a psychological gap. We know the objects fall. We know they land somewhere. But the absence of sensory confirmation allows the mind to file the event away as resolved. Out of sight becomes out of mind. There is also a subtle shift in how value is perceived. Objects that cost billions to design, build and launch become, in their final moments, hazards to be managed. Their worth is no longer measured in function, but in risk. The safest outcome is not preservation, but disappearance. This inversion is striking. The same technology that carried humans and instruments above the planet ends its life by being erased from human spaces entirely. It returns not to museums or scrapyards, but to a place defined by absence. From a certain perspective, this is fitting. Exploration often ends quietly. Tools wear out. Frontiers close. What remains is residue rather than triumph. There are, however, layers of complexity beneath this narrative. Not all materials behave the same way in the ocean. Metals corrode at different rates. Some alloys resist degradation. Composites break down unpredictably. Paints, foams, and insulating materials fragment into smaller pieces over time. These processes are slow, but they are not inert. The deep ocean does not flush contaminants quickly. Circulation is sluggish. Chemical exchange occurs over long time scales. A fragment resting on the seafloor may influence its immediate surroundings for decades or longer. Again, scale matters. The total mass of debris deposited here is tiny compared to the mass of the ocean. But the ecosystem is sparse and slow to respond. Recovery from disturbance, even small disturbance, takes time. This complicates the idea that falling objects simply vanish. They do not. They transform. They diffuse. They enter systems we do not fully understand. It also complicates the language we use. Symmetry suggests rest, finality, containment. In reality, the ocean does not offer rest. It offers redistribution. Everything introduced is eventually moved, altered, incorporated. That incorporation blurs the boundary between natural and artificial. Over long periods, materials introduced by humans become just another sediment layer, another chemical signature, another anomaly future scientists might puzzle over. There is a strange symmetry here. Just as we study ancient meteor impacts by reading layers of rock, future observers might read traces of space activity in ocean sediments. A thin band of unusual alloys, isotopic signatures, evidence of a time when humans regularly placed machines into orbit and then guided them back down. From this perspective, falling objects from the sky are not isolated events. They are part of a longer story about how a technological species interacts with its environment, how it manages risk, how it chooses where consequences are acceptable. Point Nemo, as a destination for these falls, becomes a kind of ledger, not a visible one, but a conceptual one. Each descent records a decision. Each fragment marks an end. This does not mean the practice is reckless. On the contrary, it is carefully controlled and monitored. But control does not equal neutrality. every solution reflects values, priorities, and assumptions. One of those assumptions is that emptiness can absorb impact without protest. The ocean challenges that assumption quietly. It does not resist in ways we easily recognize. It does not push debris back to the surface. It does not signal distress. Its responses are slow, chemical, biological, and largely invisible. That invisibility invites complacency. It makes it easier to focus on immediate safety rather than long-term subtle effects. As more objects fall, the story of this place becomes layered not just with sediment, but with intention. It is no longer just the loneliest point on Earth. It is a chosen endpoint, a deliberate destination for endings, and endings, even controlled ones, shape what comes next. Because once a place is used this way, it becomes part of infrastructure. It enters planning documents. It is referenced in risk models. It gains a function. The middle of nowhere starts to matter operationally. That shift raises new questions. If machines fall here unseen, what else might we be overlooking? What happens when attention finally turns downward, toward the seafloor where these fragments rest? What do we find when we look closely at the accumulation, the corrosion, the quiet aftermath? Because the story does not end when objects hit the water. It continues slowly, out of sight, in a place few have ever visited and even fewer have studied in detail. And beneath the waves, where debris settles among sediment and life, another layer of mystery waits. By the time anything reaches the seafloor beneath Point Nemo, it has already lost its identity. Whatever name it once carried, whatever mission patch or serial number it bore, whatever role it played in orbit, all of that has been stripped away during descent. Heat erased markings. Stress fractured structure. The ocean completed the process by separating function from form. What arrives at the bottom is no longer a spacecraft. It is a collection of shapes that do not belong. Calling them ghosts is not entirely metaphorical. These machines persist without purpose, presence without activity. They are not alive, not operating, not communicating. They do not move on their own. They do not respond. They simply exist, embedded in an environment that was never designed to receive them. The seafloor here is not a hard surface. It is soft, layered sediment, compacted slowly over geological time. When heavy objects arrive, they do not always remain visible. Some strike the bottom with enough force to partially bury themselves. Others settle gently, sinking a few centimetres before coming to rest. Over time, fine particles drift down and accumulate, slowly covering exposed surfaces. This means that many fragments disappear not because they dissolve, but because they are swallowed. Years later, even high-resolution sonar might miss them. They become part of the stratigraphy, indistinguishable from natural debris unless sampled directly. For the pieces that remain exposed, change is inevitable. Seawater is corrosive, especially under pressure and cold. Metals oxidize, alloys degrade, joints weaken. What once resisted the vacuum of space yields to slow chemical attack. The process is not dramatic. No sudden collapse, just steady alteration. This corrosion creates surfaces that life can use. Bacteria are often the first to arrive, forming biofilms that coat exposed materials. These microbial communities do not care whether a surface is natural rock or manufactured metal. They respond to chemistry and texture. If a fragment offers a place to attach and extract energy, it becomes habitat. Over time, small invertebrates may colonize these surfaces. Worms, crustaceans, organisms adapted to scarcity and darkness. The machine fragments become artificial reefs of a sort, though far less vibrant than those in shallower waters. Still, they alter local conditions. They create micro-environments, shadows, hard edges in an otherwise soft landscape. This process blurs distinctions we tend to hold on to. Natural versus artificial. Pollution versus structure. The ocean does not categorize, it integrates. From a human perspective, this integration feels unsettling because it erases intention. These machines were built for precision, for control, for purpose. Their afterlife is none of those things. They do not continue their mission in any meaningful way. They simply decay. What remains is history without narrative. There are no plaques, no records on site, no visible indication of what fell where or when. Each fragment exists in isolation from its story. A future researcher encountering one might recognize it as artificial, but without context, its origin would be ambiguous. This is how ghosts operate. They persist without explanation. The idea of a machine graveyard often suggests concentration, but that is misleading here. There is no single pile, no dense cluster of wreckage. The seafloor beneath this region is vast, and debris is spread thinly across it. Finding any specific fragment would be like searching for a single grain of sand in a desert. This dispersion reinforces invisibility. There is no critical mass to draw attention, no accumulation that demands intervention. Each object is small relative to the space it occupies. That scale mismatch is key to understanding why this practice feels acceptable. When impact is diluted across such an enormous area, it appears negligible, and in many respects, it is. But negligible does not mean non-existent. One of the most interesting aspects of these machine ghosts is that they exist in a time regime completely unlike the one they were built for. In orbit, objects move fast, systems update constantly, decisions are made in seconds. On the seafloor, everything slows down. Chemical reactions unfold over years. Biological colonization progresses at a measured pace. Structural change is incremental. A fragment that survives re-entry may remain recognizable for decades. Longer, in some cases. Its transformation into sediment will not be complete for a very long time. In this sense, these machines outlive their usefulness by orders of magnitude. This raises a question about legacy. Not in a sentimental sense, but in a material one. What traces do we leave behind when our technologies outlast our intentions? The deep ocean is becoming an archive of that question. It is not the only archive, of course. Landfills, mining sites, and industrial zones hold far greater quantities of human material. But those places are visible. They are acknowledged. They exist within regulatory and social frameworks. The seafloor here exists outside most of those frameworks. It is beyond jurisdiction, beyond routine monitoring, beyond public awareness. That makes it a particularly quiet archive. Quiet, but not inert. Some materials introduced here interact with seawater in ways that alter local chemistry. Paints and coatings degrade into particles. Insulation materials fragment. Even metals release ions as they corrode. These processes are slow, but they are continuous. In a high-energy environment, such changes might be quickly dispersed. In the deep ocean, dispersion is limited. Currents move slowly. Mixing occurs over long time scales. Local effects can persist longer than expected. Again, scale matters. The quantities involved are small. There is no evidence of widespread ecological harm, but the system's sensitivity is not well understood. Sparse ecosystems respond differently than dense ones. Recovery from disturbance takes longer when growth rates are low. This uncertainty is part of what gives these machine ghosts their unsettling quality. Not because they represent immediate danger, but because they exist beyond feedback. There is no easy way to observe long-term effects. No simple metric to confirm safety over centuries. The ghosts also challenge our sense of closure. On land, when a machine is decommissioned, it is dismantled, recycled, stored. There is a clear end-of-life process. In orbit, deorbiting feels like resolution. The object is removed from service. The risk is managed. But on the seafloor, there is no equivalent ritual, no acknowledgement that something has arrived and will remain. The machine simply transitions from one category of invisibility to another. This invisibility can create moral distance. It allows us to think of the process as clean, even elegant, and in many ways it is. Controlled re-entry is far safer than uncontrolled decay. It reflects responsibility. Still, responsibility exists on a spectrum. Managing immediate risk is one part of it. Considering long-term integration into slow-moving systems is another. The ghosts of machines force that consideration, even if only implicitly. There is also a symbolic layer worth examining. These objects represent some of humanity's most advanced achievements: space stations, satellites, vehicles designed to operate in vacuum and extreme temperature. Their final resting place is not a museum or a preserved site, but the darkest, quietest part of the ocean. This inversion can feel humbling. It suggests that no matter how advanced our technologies become, they ultimately return to environments that operate on scales we do not control. Time erodes complexity. Chemistry reclaims structure. Purpose dissolves. Some might find this perspective comforting, a reminder that nothing lasts forever, that even our most ambitious creations are temporary. Others might find it troubling, a sign that we are exporting complexity into places where we do not fully understand the consequences. Both reactions are valid. They reflect different priorities and different comfort levels with uncertainty. It is also important to note that these ghosts are not the only machines on the seafloor. Shipwrecks litter the oceans. Cables snake across basins. Drilling equipment rests abandoned in various places. What makes Point Nemo distinct is not the presence of machines, but the absence of everything else. A shipwreck near a coast becomes part of a narrative. It attracts divers. It enters local lore. It may even become a protected site. A fragment beneath Point Nemo does none of that. It remains anonymous. Anonymity changes how we relate to objects. Without a story, it is harder to care. Without visibility, it is easier to ignore. And yet, the ocean does not ignore. It processes. Over long periods, these machine fragments will be altered beyond recognition. Metals will become minerals. Composites will fragment into particles. Eventually, they will be indistinguishable from surrounding sediment. Their origin will be detectable only through subtle chemical signatures. In geological terms, this is not unusual. Meteorites have fallen into oceans for billions of years. Volcanic material accumulates. Continental erosion feeds sediment. Human-made objects become just another input. The difference lies in intentionality. Meteorites are natural. Volcanic ash is natural. Machine debris is deliberate. It reflects choices. Those choices are not malicious. They are pragmatic. But pragmatism does not eliminate responsibility. It simply defines the boundaries within which responsibility is considered. As awareness of Point Nemo grows, so too does awareness of these ghosts. They shift from being purely theoretical to being part of the story. They force a more nuanced understanding of what emptiness really means. Empty does not mean untouched. Silent does not mean inactive. Isolated does not mean irrelevant. The ghosts of machines on the seafloor are reminders of that complexity. They are quiet markers of a technological era, resting in a place chosen precisely because few would ever look. But eventually looking happens, curiosity spreads, questions follow. What else lies down there? Not just debris but patterns, signals, anomalies, things satellites cannot see. Because for all our mapping and monitoring, there are still limits to what we can observe from above, and those limits become especially apparent in places where nothing calls attention to itself. Which brings us to another layer of mystery. What escapes detection entirely? What remains hidden even when we know exactly where to look? Because absence of evidence is not evidence of absence, especially in the deepest, quietest parts of the ocean. Satellites give us a comforting illusion. From far above the Earth, they provide clean lines, crisp images, and the sense that the planet has been neatly catalogued. Coastlines traced, clouds mapped, temperatures measured, movements tracked. When we look at satellite imagery, it feels like seeing everything at once, as if nothing significant could possibly escape notice. And yet, this confidence quietly collapses over the open ocean, especially above Point Nemo. From orbit, this region looks deceptively simple. An uninterrupted expanse of blue, no ships leaving wakes, no oil platforms, no city lights, no obvious activity. The sensors report what they are designed to report, and what they report suggests absence. But that simplicity is not completeness. It is limitation. Satellites are excellent at observing surfaces. They struggle with depth. Light-based imaging can only penetrate the ocean to a limited extent. Even the clearest water absorbs and scatters sunlight rapidly. A few tens of meters down, detail vanishes. Beyond that, the ocean becomes opaque. To satellites, everything below that thin surface layer might as well not exist. This creates a sharp boundary between what is visible and what is merely inferred. We know the ocean is deep. We know life exists below. We know debris sinks, but we do not see any of it directly from space. The satellite's view ends almost as soon as it begins. Other sensors extend this reach slightly. Radar can detect surface roughness. Altimeters can measure sea surface height to infer currents and seafloor features indirectly. Gravimetric measurements reveal subtle variations caused by underwater mountains and trenches. But these are abstractions, mathematical reconstructions. They tell us that something is there, not what it is or how it behaves. This distinction matters more than we usually acknowledge. When a satellite looks at land, what it sees is generally aligned with human perception. Mountains appear where mountains exist. Rivers trace paths we recognize. Changes over time, such as deforestation or urban growth, are visually obvious. The satellite's eye reinforces our intuition. Over the open ocean, that alignment breaks. The satellite sees uniformity where complexity exists. It reports calm where slow processes are unfolding. It registers nothing where something subtle is happening. Point Nemo exemplifies this disconnect. To satellites, it is unremarkable. There is no anomaly in colour or temperature that distinguishes it from surrounding waters. There are no recurring patterns that demand attention. It is, from above, just another part of the Pacific, and yet we know that beneath that surface lies a layered world of currents, chemistry, life, and debris. We know machines rest on the seafloor. We know microbial ecosystems persist. We know sound travels differently here. None of this is visible. This invisibility shapes how we think. What we can see feels real. What we cannot see feels abstract. Decisions tend to prioritize the visible. This is not a flaw unique to satellites. It is a broader human bias. We respond to what presents itself clearly. The deep ocean resists presentation. Even changes that do affect the surface can go unnoticed. Subtle chemical shifts do not alter colour dramatically. Low-level biological activity does not create blooms. Slow accumulation of material does not produce immediate visual cues. A satellite can tell you that nothing dramatic is happening. It cannot tell you that something slow is. This matters because slowness is where many long-term consequences hide. The deep ocean operates on extended timescales. Reactions unfold over decades. Impacts compound quietly. Feedback loops are delayed. When satellites fail to detect change, it can be mistaken for stability. In reality, stability and invisibility are not the same. There is also the issue of resolution. Satellites are optimized to cover large areas. They trade detail for scope. This is sensible, but it means small-scale phenomena vanish into averages. A single object on the seafloor is invisible. A cluster of objects spread across thousands of square kilometers is still invisible. Even when something is theoretically detectable, it may not be prioritized. Monitoring resources are finite. Attention is directed toward places with economic, strategic, or human importance. Regions like Point Nemo fall low on that list, not because they are unimportant, but because they do not demand attention. This creates a feedback loop. Because nothing is observed, nothing is studied. Because nothing is studied, nothing is reported. Because nothing is reported, the region remains invisible. This loop reinforces the idea that emptiness is self-evident. It also shapes scientific knowledge. Oceanography relies heavily on in situ measurements, buoys, floats, research vessels. These instruments are expensive to deploy and maintain. They are placed strategically. Shipping routes, climate-critical regions, coastal zones. The ocean's loneliest coordinates are not strategic in this sense. They do not influence weather patterns dramatically. They are not near land-based economies. They do not host known hazards. As a result, they receive less direct measurement. This does not mean we know nothing about the region. Models fill gaps. Data from nearby areas are extrapolated. But models are only as good as their assumptions. They smooth over variability. They generalize. What we cannot see directly becomes statistically represented rather than observed. There is also a psychological dimension to satellite blindness. Seeing the Earth from space fosters a sense of mastery. We feel that the planet is known, measured, understood. This feeling is reinforced by colourful maps and real-time data streams. Point Nemo punctures that confidence quietly. It reminds us that knowing where something is does not mean knowing what is happening there. The ocean, in particular, resists surveillance. It hides depth behind surface uniformity. It absorbs sound. It disperses matter slowly. It erases tracks. This resistance is not adversarial. It is structural. The ocean was not built to be seen from above. The implications extend beyond curiosity. Environmental monitoring depends on visibility. Conservation depends on awareness. Regulation depends on detection. When regions remain unseen, they fall outside these systems almost by default. This is why deep-sea ecosystems were ignored for so long. They were assumed to be static, barren, resilient. Only when direct exploration revealed their complexity did attitudes begin to shift. Point Nemo has not undergone that shift yet. Not fully. It remains defined more by what it lacks than by what it contains. The satellites continue to pass overhead, collecting data that says very little. The maps remain clean. The graphs remain flat. And beneath that calm surface, processes continue. This gap between perception and reality invites caution. It suggests that absence of evidence should not be confused with evidence of absence, especially in environments designed by physics to hide change. It also invites humility. Our tools are powerful, but they are not omniscient. They reveal what they are designed to reveal. Everything else remains in shadow. As technology advances, some of these shadows will recede. Better sensors, autonomous underwater vehicles, long-duration deep-sea observatories. Over time, the unseen becomes seen, but there will always be limits. The ocean is vast. Attention is finite. Some places will remain peripheral. Point Nemo sits at that periphery. Not because it is unimportant, but because it does not announce itself. And yet, even unseen, it affects us. It absorbs our decisions. It records our actions. It hosts processes that connect slowly to the rest of the planet. Recognizing what we cannot see changes how we interpret what we think we know. It shifts emphasis from certainty to curiosity. And once curiosity enters, another question follows naturally. How does such extreme isolation affect the human mind? Not in theory, but in practice. What happens when distance, silence, and invisibility converge not on a map, but in experience? Because the mystery of Point Nemo is not only environmental, it is psychological as well. Isolation does something subtle to time, not to clocks or calendars, but to the way the mind experiences duration, sequence, and meaning. Remove landmarks, remove routine, remove the steady stream of signals that normally divide one moment from the next, and time begins to loosen its structure. It does not stop. It stretches. It thins. It becomes less cooperative. This effect is not theoretical. it has been observed repeatedly in environments far less remote than Point Nemo. Polar stations, submarines, long sea voyages, space missions. Anywhere distance and disconnection converge, the human mind begins to reorganize how it relates to time. We tend to think of isolation as a spatial condition, but psychologically, it is temporal first. The absence of people matters, but what matters more is the absence of interruption. On land, time is constantly punctuated. Conversations begin and end, traffic lights change, notifications arrive, meals follow schedules. Even boredom has texture because it is surrounded by cues. In extreme isolation, many of those cues vanish. At sea, especially in open water far from routes or destinations, days lose contrast. There is no approaching city to signal progress, no diminishing distance to create anticipation. The environment does not acknowledge your movement in a way that registers emotionally. You may be travelling hundreds of kilometres, but nothing looks different when you wake up than when you went to sleep. This creates what psychologists sometimes call temporal flattening. Events still occur, but they feel less distinct. Without novelty or social reference, memory compresses. Looking back, a week can feel like a single long day, or a day can feel endlessly extended depending on attention and emotional state. At Point Nemo, this effect would be amplified by the knowledge of isolation itself. Awareness matters. A person crossing an empty ocean while knowing that land lies a few hundred kilometres away experiences distance differently than someone who knows land is equally distant in every direction. The second case removes orientation not just physically, but mentally. There is no sense of moving towards something. Human cognition is goal-oriented. Even when goals are abstract, they provide structure. Isolation without destination deprives the mind of that scaffolding. Time no longer flows toward arrival, it simply passes. This has been documented in long-duration space missions, where astronauts report changes in time perception despite tightly scheduled days. Even with structure imposed, the awareness of separation from Earth alters subjective time. Days can feel both rushed and empty. Weeks blur together. The mind oscillates between hyper-focus and drifting attention. In the open ocean, similar effects appear. Sailors on extended passages often report a detachment from conventional timekeeping. Watches still tick. Logs are still kept. But the felt experience diverges. The ocean imposes its own rhythm. Swells rise and fall. Wind shifts slowly. Light changes with the sun. These cycles replace clocks as reference points. At Point Nemo, where human rhythms are least reinforced, this substitution would be nearly complete. The mind would anchor itself to environmental repetition rather than social structure. Dawn and dusk would matter more than dates. Weather would matter more than plans. Isolation also alters internal dialogue. Without frequent interaction, thoughts tend to loop. Conversations replay. Imagined futures become more vivid. Minor concerns can grow larger simply because there is nothing to interrupt them. This is not necessarily negative, but it is intense. Some people find that isolation sharpens introspection. Others find it uncomfortable. The difference often lies in tolerance for unstructured time. Those accustomed to constant stimulation may experience anxiety when that stimulation disappears. Those comfortable with solitude may find relief. Point Nemo represents an extreme version of this test. Not because anyone routinely spends time there, but because it concentrates every isolating factor at once. Distance from people, distance from land, absence of signals, environmental sameness, knowledge that help is far away. This knowledge alone can alter cognition. Even without immediate danger, the awareness of vulnerability changes how the mind processes information. Risk feels amplified, decisions feel heavier, attention narrows. This narrowing can be adaptive. It encourages caution, it reduces impulsivity, but over time, it can also lead to mental fatigue. Constant self-monitoring is exhausting. time perception shifts again here. Under sustained vigilance, time may seem to slow. Each hour feels significant. Each decision carries weight. In contrast, periods of monotony can cause time to disappear entirely. Hours pass unnoticed because nothing demands engagement. This oscillation between stretched and compressed time is characteristic of extreme isolation. It is not a flaw. It is the brain adapting to unusual conditions. Memory formation is also affected. The brain prioritizes novelty when encoding experiences. In environments with low variation, fewer distinct memories are formed. Later, when recalling the period, it feels shorter than it actually was. This is one reason extended voyages can seem to vanish in hindsight, even if they felt long while occurring. At Point Nemo, where variation is minimal, this compression would be pronounced. Without changes in scenery, without social interaction, without external milestones, memory would have fewer anchors. This has implications beyond individual experience. It affects how isolation is reported, remembered, and communicated. Accounts from remote environments often emphasize moments of change precisely because they stand out. A storm, a mechanical issue, a rare sighting. These become narrative focal points. Everything else fades. The human mind also has a complicated relationship with emptiness. We are uncomfortable with nothing happening. When external stimuli diminish, internal stimuli intensify. Thoughts, memories, and imagined scenarios fill the space. This can be constructive. Many people report creative insights during periods of isolation. Without distraction, the mind explores connections it normally ignores. But it can also be destabilizing. Without external grounding, worries can spiral, perspective can narrow. At Point Nemo, there would be no easy way to recalibrate through social contact or environmental change. The ocean would continue being the ocean. The sky would continue being the sky. This is why isolation training for astronauts and polar researchers includes psychological preparation. The challenge is not boredom, it is meaning. Maintaining a sense of purpose when the environment offers none. Humans are meaning-making creatures. We interpret surroundings constantly. We read signals. We assign significance. In an environment that offers few signals, the mind must generate its own. Some people respond by anthropomorphizing the environment. The ocean becomes watchful. The silence feels intentional. This is not irrational. It is the brain seeking patterns. Others respond by turning inward, journaling, counting time, creating rituals. These behaviors impose structure where none exists. They are adaptive strategies, not quirks. At Point Nemo, any sustained human presence would require such strategies. Not because the place is hostile, but because it is indifferent. Indifference is harder to cope with than hostility. Hostility provides feedback. Indifference does not. Time also becomes heavier when isolation removes social synchronization. On land, time is shared. Meetings happen. Events occur simultaneously for many people. This shared experience anchors perception. In isolation, time becomes private. There is no external confirmation that a moment matters. This privatization of time can feel freeing or disorienting. Without comparison, urgency fades. Deadlines lose meaning, but so can motivation. This dynamic has been observed in environments with extreme remoteness. Some individuals thrive, others struggle. The difference often lies not in personality, but in context and support. Point Nemo lacks context by definition. It is not embedded in a narrative of exploration or habitation. It is not a destination people train for. It exists as an idea more than a place of experience. This makes its psychological weight largely hypothetical, but that does not diminish its relevance. Hypothetical extremes are powerful because they test assumptions. They reveal where our intuitions break down. Imagining time at Point Nemo forces us to confront how much of our sense of self depends on proximity, on feedback, on being seen. In a place where no one is watching, Where no one is nearby, the usual social mirrors disappear. Identity becomes internal rather than reinforced. For some, this is clarity. For others, it is erosion. There is also a subtle shift in how future and past are perceived. In isolation, the future can feel distant and abstract. Plans lose immediacy. The past can feel closer, replayed repeatedly in thought. This temporal imbalance can affect mood and decision-making. Again, this is not unique to Point Nemo. It appears wherever isolation persists, but the extremity of the coordinates makes it a useful reference point. Time, in such a place, is no longer measured by progress towards something. It is measured by endurance, by maintenance, by continuation. This reframing changes priorities. Small comforts matter more, routines become anchors, the environment stops being something to conquer and becomes something to coexist with. If humans were ever to spend extended time at Point Nemo, which is unlikely, the challenge would not be physical survival alone. It would be cognitive equilibrium, maintaining attention without fixation, maintaining awareness without anxiety, allowing time to pass without losing meaning. This balance is delicate. The fact that most people will never experience this environment directly does not make it irrelevant. We encounter diluted versions of this isolation in everyday life, long stretches of repetitive work, periods of social disconnection, moments when the world feels distant and unresponsive. Point Nemo magnifies those experiences until they are impossible to ignore. That is why it occupies such a persistent place in imagination. It is not just about geography, it is about the edges of human tolerance for emptiness. As this psychological dimension becomes clearer, it intersects with another, quieter reaction. Unease. A sense that something about this place is not just empty, but unsettling in a way that resists explanation. This unease does not come from danger or horror. It comes from scale, indifference, and the realization that some places exist entirely outside our usual frameworks of meaning. And that realization leads naturally into the next layer of the mystery. Why does a place with no obvious threat feel so unsettling to so many people? Because isolation does not just challenge the mind, it challenges intuition itself. There is nothing overtly threatening about Point Nemo, no towering cliffs, no violent storms that occur there more often than anywhere else in the South Pacific, no legends of monsters or curses tied to the coordinates, and yet, for many people, simply knowing that this place exists produces a faint but persistent discomfort. Not fear in the usual sense, not panic. Something quieter, something harder to name. Unsettling is the word most often used, and it fits precisely because it does not imply danger. It implies misalignment, a subtle wrongness, a sense that familiar mental tools do not quite work there. One reason this feeling arises is that Point Nemo violates expectation without breaking rules. Humans are accustomed to extremes announcing themselves. The highest mountain is visible, the deepest canyon is dramatic, the coldest places hurt immediately. We expect the edges of the world to feel sharp. Point Nemo does not. It feels flat. That flatness is disorienting because it removes narrative. There is no story of ascent or descent, no transition from safe to unsafe, no threshold that marks entry into a special zone. You could cross directly over the coordinates without knowing it. Nothing would change. This absence of sensory confirmation undermines trust in intuition. We rely on environmental cues to tell us when we are somewhere unusual. At Point Nemo, those cues are missing. The mind knows something is different, but the body receives no supporting evidence. That mismatch creates cognitive tension. Another source of unease is the collapse of proximity. Humans evolved in environments where help was usually nearby. Even in isolated settings, there was often a horizon that promised eventual contact. A valley leading to another valley, a coastline hinting at settlements beyond sight. At Point Nemo, that promise disappears. Not gradually, but completely. Land is not just out of sight, it is equally distant in all directions. There is no closer option, no better heading. This symmetry removes hope in its most basic navigational form. The mind is not comfortable with equal outcomes. We are wired to compare, to choose, to optimize. When all choices lead to the same result, decision-making stalls. That stalling is felt as discomfort. There is also the issue of scale. Humans can imagine large distances, but only by breaking them into parts. We think in terms of stages, miles between towns, hours between stops. When distance becomes too large and too uniform, those mental partitions dissolve. Point Nemo's distances resist segmentation. You cannot easily imagine being halfway to land, because halfway is still impossibly far. There is no meaningful midpoint. This undermines one of the brain's primary coping mechanisms for dealing with magnitude. The ocean itself contributes to the unease in subtle ways. Water is a boundary humans do not naturally belong to. We can survive in it only briefly and with effort. On land, even in remote regions, the ground offers a sense of stability. You can stop, sit, build shelter. At sea there is no resting place. The surface moves constantly. Even calm water shifts beneath you. The horizon remains unreachable. There is no equivalent of standing still. This perpetual motion without progress amplifies psychological strain. It creates a sense of suspension rather than travel, of being held in place by something that does not care whether you move or not. The absence of sound, or rather the absence of familiar sound, deepens this effect. Without engines, voices, or mechanical noise, the auditory environment becomes abstract. The ocean produces sound, but it is not conversational. It does not respond. Humans are accustomed to feedback. Even echoes provide confirmation of presence. In extreme quiet, that feedback disappears. You speak, and nothing answers. You listen, and nothing speaks. This can feel like erasure. Another unsettling aspect is invisibility. Not just being unseen by others, but knowing that nothing is watching. In most environments, the possibility of observation is constant. Someone might pass by, something might notice. At Point Nemo, that possibility approaches zero. There is no accidental witness, no chance encounter. If something were to happen there, it would happen alone. This awareness triggers a deep-seated vulnerability. It removes the safety net of chance. Humans often survive not through planning, but through coincidence. Being in the right place at the right time. At Point Nemo, coincidence does not favour rescue. The fact that the nearest humans are often in orbit rather than on Earth compounds this feeling. It reframes isolation in a way that feels almost unreal. Help exists above, not around. Close in one sense, unreachable in another. This inversion disrupts spatial intuition. We do not normally think of safety as something overhead. There is also a cultural element at play. Emptiness has historically been treated with suspicion. Blank spaces on maps were once labelled with warnings. Here be dragons. Not because danger was known, but because absence itself felt threatening. Modern mapping removed those warnings, but the instinct remains. When a place is described primarily by what is not there, the imagination fills the gap. Point Nemo invites projection. Some imagine it as peaceful, others imagine it as oppressive. Both reactions stem from the same uncertainty. The environment does not guide interpretation. This ambiguity is unsettling because it denies closure. There is no correct emotional response, no established narrative to lean on. The association with falling spacecraft adds another layer. Even if the risk is minimal and controlled, the idea that objects burn and break apart above this region reinforces its role as a place for endings. Final descents, disappearances. Humans are uncomfortable with places associated with disposal, even when disposal is necessary. Landfills, graveyards, test sites, they carry a psychological weight disproportionate to their physical danger. Point Nemo inherits that weight quietly. It becomes a place where things go away. There is also the matter of permanence, or lack thereof. The ocean erases evidence, debris sinks, traces disperse. Nothing remains visible to mark what has occurred. This erasure unsettles because humans rely on traces to make sense of the past. Ruins, records, scars. Without them, events feel unreal, unresolved. At Point Nemo, the absence of traces is almost complete. History happens and is immediately submerged. This challenges the idea that meaning requires witness. It raises the uncomfortable possibility that things can occur without being acknowledged at all. The mind resists this notion. We want events to matter. We want them to be seen. When a place offers no mechanism for recognition, it feels wrong. There is also a deeper existential layer. Point Nemo represents a limit to human relevance, not in the sense that humans cannot reach it, but in the sense that our presence does not matter there. The ocean does not change in response to us. It does not accommodate. It does not react. It simply continues. This indifference contrasts sharply with environments shaped by human activity, where every action leaves a visible mark. At Point Nemo, marks are absorbed and erased. For some, this is humbling in a healthy way, a reminder that the world is larger than us. For others, it is deeply unsettling, a reminder that we are not central. The unsettling feeling also stems from abstraction. Most people will never experience this place directly. It exists as an idea. Ideas can be more disturbing than experiences because they bypass sensory grounding. You cannot reassure yourself by touching something solid or seeing a familiar shape. The mind operates entirely on description and imagination. Imagination, left unanchored, tends toward extremes. Another factor is irreversibility. If something goes wrong at Point Nemo, reversal is not an option. There is no easy return, no nearby refuge. This finality weighs on thought even when no immediate risk exists. Humans are comforted by the option to retreat. Knowing you could leave if you needed to is often enough. At Point Nemo, that option exists only in theory, not in practice. The environment does not trap you, but it does not help you leave either. This sense of being unsupported by surroundings is subtle but powerful. It shifts responsibility entirely inward. Every decision feels amplified because there is no buffer. The unsettling nature of the place also reflects a broader discomfort with limits. We live in a world that emphasizes access, connectivity, and reach. Point Nemo represents the opposite. It is a limit not imposed by law or technology, but by geometry and scale. You can reach it, but reaching it does not give you control. This undermines a common narrative of progress. The idea that every place can be mastered, optimized, integrated. Point Nemo resists integration. It remains peripheral. Peripheral places challenge the assumption that relevance is universal. Finally, there is the simple fact that this place does not care how we feel about it. All the unease exists entirely on our side of the equation. The ocean does not respond to being called unsettling. It does not become more or less isolated based on our interpretation. That asymmetry is uncomfortable. We're used to environments that react, that reflect us back to ourselves. Point Nemo does not. It exists as a reminder that some parts of the world operate entirely outside our emotional frameworks. They are not hostile. They are not welcoming. They are simply indifferent. Indifference, more than danger, is what unsettles us most. As this realization settles, it begins to soften. Unease often does. Once named, once understood, it loses some of its edge. What remains is not fear, but perspective. And that perspective invites a final shift, away from discomfort and toward reflection. If a place so empty can provoke such strong reactions, what does that say about us? About how we define meaning, connection, and importance? Because after tracing distance, silence, life, machines, and the limits of perception, the story of this place does not end with unease. It ends with return. Not a physical return, but a mental one. A movement back toward the world we inhabit. carrying with us a quieter understanding of how small and how connected we really are. Returning from the most distant place on Earth does not involve movement in the usual sense. There's no ship turning toward home, no horizon gradually changing, no coastline rising from the water. The return happens internally, through recalibration. After spending time thinking about a place defined by distance, absence, and indifference, the mind begins to notice proximity again. Familiarity regains weight. Connection feels heavier, more tangible. Point Nemo does not invite reflection, because it offers answers. It does so because it removes context. When stripped of landmarks, neighbours, signals, and destinations, the mind is forced to confront what it relies on to feel oriented. What remains after everything external is reduced to water, sky, and time. In imagining this place, something subtle happens. Everyday distances start to feel smaller. The gap between cities, the time it takes to reach another person, the effort required to be present somewhere else. These distances regain proportion. They stop feeling absolute and start feeling negotiable. This shift is not dramatic. It doesn't announce itself. It appears quietly as a change in how absence is perceived. After considering a place where absence is nearly total, the partial absences of daily life lose some of their weight. A delayed message feels less severe. A quiet room feels less empty. Silence stops implying neglect and starts implying space. Returning in this sense is not about leaving Point Nemo behind. It is about carrying its perspective forward. One of the quiet lessons of the most distant place on Earth is that distance itself is not inherently meaningful. It becomes meaningful only when placed in relation to something else. Land matters because we live on it. Signals matter because we expect them. Neighbours matter because we depend on them. Point Nemo removes those expectations. It exposes how much meaning is constructed through comparison. When you step back into the familiar world, that construction becomes visible. Streets feel denser, voices feel closer, the presence of others becomes more pronounced, not because they changed, but because your reference point did. There is also a recalibration of urgency. In a place where nothing responds quickly, speed loses importance. Decisions slow down, outcomes stretch. This imagined slowness can linger after the thought experiment ends. It creates a brief resistance to rush. Tasks still need doing. Time still passes. But the pressure softens. The world feels slightly less demanding. This is not escapism, it is context. The most distant place on Earth does not offer solutions to daily problems. It does not provide clarity in the way advice does. Instead, it offers scale, and scale changes how problems feel. A concern that once seemed overwhelming can feel contained when placed against the idea of thousands of kilometers of uninterrupted ocean. Not because the concern is invalid, but because its boundaries become clearer. Another subtle change involves attention. Point Nemo resists attention. It does not reward scrutiny with detail. That resistance teaches restraint. It reminds the mind that not everything benefits from constant focus. Returning from that mental environment, attention can loosen its grip. Not everything needs to be analysed immediately. Some things can exist without interpretation. This is particularly relevant in a world saturated with information. Signals arrive constantly. Updates demand reaction. Noise fills gaps automatically. Point Nemo represents the opposite condition, a place where nothing calls out. After spending time there, even in thought, the contrast becomes apparent. The constant stimulation of daily life stands out. It becomes easier to choose when to engage and when to step back. There is also a renewed awareness of infrastructure. Roads, power lines, communication networks. These systems fade into the background because they usually work. At Point Nemo, their absence is defining. Returning makes their presence noticeable again. Not as something to take for granted, but as something quietly remarkable. The fact that voices can travel instantly. that help is nearby, that movement leads somewhere. This awareness does not require gratitude in a sentimental sense. It simply restores proportion. Another aspect of return is recognizing limits. Point Nemo exists because there are limits to how land is distributed across the planet, limits to proximity, limits to accessibility. These limits are not failures, they are features of reality. Returning with that understanding can ease the pressure to overcome every boundary. Some boundaries exist without needing to be crossed. This realization can be calming. It allows for acceptance without resignation. There is also a gentler understanding of solitude. Point Nemo shows solitude at its most extreme, stripped of romance and threat. Just absence. Returning from that, everyday solitude feels different. A quiet moment no longer implies isolation. It becomes a choice rather than a condition, a pause rather than a void. The same applies to silence. Silence after considering a place defined by silence feels less empty. It becomes breathable. Even time changes slightly on return. The compression and stretching imagined in extreme isolation leave an imprint. The rigid structure of schedules feels less absolute. Time regains elasticity. Minutes can slow when needed. Hours can pass without guilt. The clock becomes a tool rather than a judge. None of these shifts are permanent. The world reasserts itself quickly. Obligations return. Noise fills space. Distance collapses back into routine. But the trace remains. A memory of scale. A reminder that the planet contains places where none of this applies. That reminder can act as a quiet anchor. When everything feels too close, too loud, too demanding, the idea of the most distant place on Earth offers contrast, not as an escape, but as a reference. It says without words that not everything is immediate, not everything is connected, and that this disconnection is not a flaw in the world. Returning also involves acknowledging that Point Nemo itself does not change because we think about it. It remains where it is, doing nothing, receiving little, indifferent to attention. This indifference is part of its value. It offers perspective without asking for engagement. It does not become diminished by being understood, nor enhanced by being ignored. In that way, it serves as a counterbalance to environments shaped entirely by human response. It reminds us that the world does not exist solely as a mirror. The return, then, is not about bringing something back from Point Nemo. It is about leaving something there. Excess urgency, excess interpretation, excess expectation. What remains is a slightly quieter internal landscape, and in that quiet, the familiar world resumes its shape. Rooms regain their edges, sounds regain their sources, people regain their presence. The distance closes, but the understanding stays open. Somewhere out there, far beyond roots and routines, a point remains that belongs to no one, speaks to nothing, and waits for nothing. Not as a destination, but as a reminder, and from that reminder, we return.